Welcome back to our course. So the first lecture is on the data types, and as I would like this course to be very practical and hands-on learning and practicing coding, etc., I right away start diving into the coding environment so we can easily test everything here together. So basically, this is the environment that I'm using here, but it's not important what environment you're using. Whatever you're using, either it's online or it is installed on your desktop, Mac, or whatever. The important thing is that you just keep trying and you just keep making mistakes and try and start doing it. It may in the beginning look like, okay, this is too easy in the beginning. I don't even need to try it, but believe me, you need to try and you need to start coding. So, in the beginning, when we have like as you see here, everything is commented. But how things are commented in C++? If we want to comment something, for example, now I would like to make some changes. As you see here, we see the red part here, meaning that we did some modification, but we haven't registered it yet. And the modification that I just made was just pushing the tab button a bit so the line would start from not from the start, but a bit further. So here we want to write something like author is Reza Shahin. So as you see, this is unknown type name for the programming language, and it returns immediately, it returns error. In order to keep some comments, we can just put two slashes here, so it is now commented. I can have this one here, like the author, the date, the I don't know, this code is the first version, for example. All these information can be commented, and then you start your code as of line 20, for example. So when I push Control S, everything is saved, and you see the green light here saying that, okay, this is now registered. So this is the first type of commenting in the code. And the second type is in C++, we can have slash star and then star slash in the end. And whatever that are between slash star and star slash are commented. As you see here, for example, for data types, it is commented, so it doesn't have any problem for the code and the compiler. Let's start from the line 1. This is the default include that we consider for the C++, and we include this one for considering a string in our code. But just by default, consider these two these two including parts. Later on the course, I would discuss different including things that we can consider and why they are important. But this is not the point of our lecture today. So these two includes are now working. The rest are commented as there are two slashes behind them. A typical C++ programming would have like a few lines for including lines and then one int main function. So when we open the int main function, the first lesson is the data types. So data types, we want to start it. As you see here, we put some information in commented, but the things that we would like to discuss in today are also commented. So I remove the slash. You see here, now we defined one integer value named a that is said to have the value 1. But we have one warning. It says that you declared one integer value and you have not used it yet. It's okay, but we are going to use it later. But it is just sending us some warning to consider. So the first data type is the integer. When we want to declare an integer value, one of the ways is to define it as int I, int, and all of them should be lowercase, equals to 1, and then we have a semicolon there. So we can also have like int When we used in a one time, we cannot say another time a. For example, I cannot reassign a. It says that redefinition of a, so there is an error. I would say a1. So a1 is 2 now. So we declare two integer variables. The first data type that we need to learn is the integer. And then we have the type float, that is for numbers that are having decimal values. So we define the float b with the value say 3.14, and we need to be careful about the semicolon in the end. Whatever we write in our C++ programming, it must end with a semicolon in a line. So it still gives us some warning saying that it is unused. Again, it's not a problem. We're going to use it. So there are two ways to define numbers that are having decimal values. The first one was float, and the second one was double. So we can also declare double when we are having a number with decimal values. And there are some, small differences between float and double that we will discuss later on in the course. However, if you want to just have a clue of the general differences, is that when we declare a number with the float type, it uses usually 4 bytes of memory, and when we declare it as a double, it uses 8 bytes of memory. So what's the difference? So it consumes the memory more. So if we are going to use a number that is larger than a certain amount, it is recommended to use double, so it gets more memory usage. But if we are going to simply use a number with decimal values that are not so much large, we can simply just declare them as a float. But how large, how small they should be to choose between float or double, this we will discuss in the comparison that we will make in the upcoming lectures. But for the moment, that is enough for you to know that there are two types, float and double, that you can declare either of them, but there are some differences in terms of the memory usage. And also double can represent a wider range of values compared to float, because because of its higher precision and larger memory size. So this is the only thing that we need to know for the moment about it. And then we have characters that we can define, like character. It is with the name char, char, and this is char name. It could be whatever. It could be like my character equals. It should be. You should really be careful about the quotations here. Like whatever you want to put there, you can put, for example, my name, Reza. It's okay, but it should be between these two quotations. If we forget about one quotation, we will have error. If we forget about two quotations, we will have error. So it must be between two quotations, and of course with a semicolon in the end. And the last one that we would like to discuss is a Boolean type. We declared an ABC named Boolean that could be whatever, like my bool, we could declare equals true. So for the Boolean, there are only two values that can be assigned, either true or false, and that's it. It's either 0 or 1. When it's true, it represents the value 1, and when it's false, it represents the value uh, when it's false, it represents the value 0. For the float number, it's the same. We can declare all the numbers with decimal values, and for the integer, it's only integer values. Sorry, for example, we cannot have an integer declaration for a and then consider having it with decimal values. It gives us some warning saying that you need to use double or maybe float for this and not the type integer. So these are the basics data types that we needed to know in the beginning. Then we learned about how to put comments. You see here now our code, we push the Control S and our code is registered. And these parts are comments. So whatever we put there, like whatever we type there, it's considered as nothing, as it is not even existed. So uh, this is the first way of putting comments, and then we have the second way of putting comments like this between slash star star slash. And finally, we learned about different data types that we declared here. In the next lecture, we dive into more details about the data types. Hello, everyone. Welcome back to this course. So in previous lecture, we learned how to declare some different data types, like as you see here, integer, float, double, characters, and booleans. In today's lecture, in today's lesson, we would like to print their values. So we declare an integer a1, for example, equals to 2. And we would like to print this integer value and see it in the terminal. Here, we prepared something for you. As you remember, everything is commented here in between. Everything is commented. So I uncomment this line. Oh, sorry, I put it more comments. So I commented this line. I uncommented this line. I declare integer a equals 1 semicolon, and it ends. So this is the declaration that we have here. And remember that we had some commented libraries and including things here. So one of them is using namespace std. So let me explain what this std is all about. So here, now I uncomment this line and we will have probably some errors if we want to run it. So if we would like to print something, we would have to write std colon colon, then cout, means that show us the output. Then we would have these two signs. And then between quotations, we would be able to have the comments that we would like to be printed in the terminal. For example, we write it here, the value of a is, and one space is put here, so, and then we close the quotation. Then we mention a, so the value of the integer that we wrote will be printed, and then we put end l. Before end l, I would write std colon colon end l. So this is how we can print it. So let's try this one to see how the result would be. I run and wait for the compiler to run my code. So here is the result. The value of a is 1. So what was the message that we typed here? So the value of a is, and then instead of this part that we put a, you see the value 1 is printed. So now that we know the value of putting the value of this integer being printed, we would like to mention that using namespace is very good. So now, if what happens if I remove this std? If I remove this std and run again the problem, we will see that we have an error. It says undeclared identifier, and also this one. If I remove them and compile, we will have 2 errors. So std is very important to be written every time, but because every time we need to write it down, it is not very convenient. Instead, we could use this using namespace std in the beginning of our program and forget about it throughout the program. So now that I uncommented that this using namespace std semicolon, we run the program again. Okay, this time we don't have any errors, and voila, it is printed. So if we are considering putting using namespace std semicolon in the beginning of our program, we can escape using it throughout the program. But if we don't mention it in the above, we need to type it every time that we are writing. So this is the first point. The second point is that the syntax for printing is cout. So when we use cout, we are sending the machine that we want to print. And the end L, let me just remove this end L so you will see how the result would be different. In this case, because we have only one printing, the result would not change, you see? Okay, so you see the press return to close this window came to the line 1. Previously, it was in the line 2. So let me print something else. Let me print it again. Let me just copy paste this line one more time. So now what happens is this. So you see the value of A is 1, the value of A is 1, press return true. So everything is printed in one line only. When we have instead, when we have the end line, we will see that it goes to the next line. So when we have the end L, we have the value of A is 1, then goes to the next line, and the value of A is 1, again press return. So if I also put the end L in here, I will see that we have 3 lines now. We should have 3 lines. Okay, you see here, so the value of A is 1, the value of A is 1, and then press return to close this window. So this shows the value of using end L in the end of the line. And so this lesson was all about the cout. So we printed the integer A1. So what about the next one? So the next one is a float type. So again, if we want to print it, we type cout. We can type a message, or we can even type nothing. But because we want our program to be clear, it would be better to type some message. For example, the value of B is, and then we put B here, and L, we Control S register, and we compile. Yes. So we see the value of B is 3.14. So easily we print this one. Again, for the double, the same thing. We can easily practice this, like cout, the value of C is, and C and L. We also have the characters and booleans. So I would write them together like this. So the value of char name is, then I put the char name here, and L. Also, we can write the value of my boolean is, then we put my boolean Just you should be very careful with the uppercase letter and lowercase letter in C++ because it is sensitive. So if I'm writing an uppercase M here, I should have the uppercase M here again. So let's check to see if we have errors or not. So we don't have any errors. Okay, great. So these are the prints. So we printed 2A, 1B. You see that the B is between quotations because here I put the quotations in the printing part. If I remove it, it will be removed. Then the C, then the char name is A because we put the value as the input A. And then the value of my boolean equals 1. Why 1? We set true. So as we mentioned earlier, for the boolean, we either have true or false. So the true equals 1 and the false equals 0. So whenever the print value is 1, just know that it is true. Whenever it is 0, just assume as false. So this is how we print our values. This is for how we print our values. And then in the next lecture, we are going to discuss about the operations using these data types. Stay tuned. Hello, welcome back. In this lecture, we are going to discuss how do we do the operations in C++. Previously, we learned how to declare data types, and we learned how to print them in the terminal. So now in this lesson, we're going to do some mathematical operations with the declared data types. So let's dive into it. We declare two integer variables. The first one is int a equals 31, and the second one is b equals 15. So previously we learned that if we want to declare an integer or any other types of data types, we can simply assign a value to them. However, in this lesson, we're going to learn that we can do some mathematical operations for the assignment of data types. For example, we have integer c assigned to be the a plus b. So instead of putting the value of like 46, we can simply let the machine and the computer do the assignment, do the math part, and then assign it to the integer c. And also, if you see here, while I was commenting this line, the 77 line, we had two warnings for 75 and 76, these two lines. We had a warning saying that, okay, you declared these two variables, integer variables, these two, but you're not using them. So why it is returning some warning? The reason that it returns some warning is that we are using some memory of the computer by declaring a new variable. And if we are not going to use it, the system, the compiler would give us some warning saying that, okay, you declared this one and you're not using it. So you may want to consider removing it to release some memory. In this level of programming, it may not be very very necessary to keep track of your memory. However, as we proceed through the coding and as we advance in programming, it is very important to manage the memory very well so we can increase the speed of the program or avoid having some memory leak problem, something like this. So for the moment, it's not important. However, now that I uncomment the line 77, we will see the warning for these two lines are disappeared. The reason is that we're using them. We declared something, A and B, and we're using them in the line 77. However, we're not using integer C. That is why we still have a warning for this line. So let's print out this line. We learned that if we are using namespace std in the beginning of our code, we don't need to write std comma comma cout every time. So here, when I have that declared in the beginning of the code, I just write C out, then I write whatever the message I would like the value of A is, and then I put the A here and L, and we run. We will see that it now needs to show us the value of A. Now it's compiling, we didn't have any error, so we see that the value of A is printed. So let's go for the next two lines. The value of B and the value of C is also printed with these commands. Let's try. We have no errors, it's compiling. Okay, so the value of A is printed like 31, the value of B is printed like 15. The value of C is also printed as 46. So the key point to today's lecture was that the math is done by the machine. We don't need to do the calculation. We just assigned the A plus B to C and it did the calculation itself, and now it's printing it. So now that we see that we have this option, we can uncomment these parts as well. Like we declare D, E, F, and G to be A minus B assigned to D, A times B assigned to E, A divided by B assigned to F, and A modulo B, which returns us the value of the remainder of when A is divided by B. So here you see we used integer C, so the warning for this line is disappeared now. So we still have the warning for the rest because we are not using them anymore. We're not using them yet, let's say. So let's print out these values to see how it would work. Now compiling, no errors. Okay, so let me bring it down here so we can compare it with the operations. Okay, now it's good. So A minus B is printed in D and stored in D. So it's 16, which is their difference. So A times B is 465, that is stored in E. We can see it in this line. And then we have the F as to be 2. So when A is divided by B, the value would be 2. And the remainder is 1, because when A is divided by B, which is 15, the remainder would be 1. If we change the value from 31, for example, to 30, we would see that the remainder should change. Compiling, no error. Let's see the result. Yes. So still we see that the A divided by B is stored in F. It is still showing number 2, which is correct. However, when we change 31 to 30, we have no remainder because these are, so 30 is 15 times 2, so no remainder is will be there when we divide A by B. So in today's lesson, we learned that the operations can be done by the machine, and we tested some beginners operations, mathematical operations, and let the machine do the mathematical formulation. In the next lecture, we are going to do the same mathematical operations, but to the float data variables. Hello again, and welcome back. Today we are going to discuss about the operations, the second part about the floats. In the previous lecture, we discussed how we do the operations for the integers. And in today's lecture, we are going to do the same operations with floats. So we declare different floats here as A, B, and then as of C, we have the operations involved in the assignment. So C equals A plus B, D equals A minus B, E equals A times B, and F equals A divided by B. So there is one thing to be very careful about when we are doing these mathematical operations for the float. So all of these operations are possible to be declared and assigned for a float, but for the module, it's not working. So this is some limitation of C++ that does not allow to use the modulo operation for the float value. So we need to be careful about it in case you're seeing this error in your compiler. You need to be careful. You need to think, oh, okay, this is not possible for the float. So it says that it invalid to binary expression float and float. So it's not possible to do the uh, module operations for the float. However, the rest of them are easy to do. It's exactly like the integer data types. So we compile, so we see no errors. So the error is gone when we commented everything about the module. So it does print the value of A indeed, the value of B, and then C as the A plus B, and then D, E, and F. So this lecture is very similar to the previous one. This is only to keep noted that we cannot use module for the float variables. Hello everyone, welcome back. In today's lesson, we are going to talk about library functions. So for the library functions, there are a few things that we need to know before we dive into the lessons. So there are some already defined functions and libraries in C++ that can help us to do some mathematical operations. And there are some reserved strings and let's say strings for performing these mathematical operations. So when we mention that there are some reserved strings for these things, it means that we cannot use these reserved ones to name our integer, to name our own newly defined string, etc. But now I will give you more information so you will get to know that. But before we go for the library functions, we go up to the code in the beginning of our code. Here, because I want to use these libraries and I want to use the already defined library functions of C++, I need to include it in the C++ program in the beginning. So don't forget to include CMath before we dive into these lesson. So in order to proceed here, we wanna show some already defined library functions in C++. So we define, as before, we define two integer values like x and y. The equals 25 and y equals 4. And as we're not using them, they are like having the warning in the code now. In order to print them, we use the syntax of cout. We know it very well now. And in the end, we put the end L to make sure that it goes to the next line for the following codes. But what are the reserved functions? The first one is sqrt. The sqrt function gives us the a square value of a number, of an integer. So when we define an integer here like x equals 25, and when we want to uh, have the square root of the x, we can simply write sqrt, and within brackets we put the number. So easily it will print us the square bracket of the integer x. So let's compile and see. So now no errors. Exactly. So the square root of 5, a square root of 5. So what we had there was something like a square root of x is 5. So the better typing would be the square root of uh, x, and then we put is the rest of the code. So this can give us a better output and more clear output. So let's check it out again. Let's try this. Yeah. So the square root of 25 is 5. So this is what it is now printing for us. So the first library function is the sqrt. The second one is that when we want to do some mathematical formulation or have some countings in our code, simply we can, for example, instead of doing the math ourselves, like 4 times 4 equals 16, we can define 4 as to be an integer named y, and the power and y to the power of 2 would be like this: po bracket y comma 2. So this code will help us to have the result of the y to the power of 2. Why we are using this? Let's see the print and then I will explain. So it says that power y2 is 16. So here I say power y, so let's say y to the power of 2 equals 16. So why do we need this formula? This formula would be helpful when we have a lot of computation that we need to do. It's easier to automatic everything in the code rather than dive into the details. So it's easier to let the machine do the formula, do the math part for you, and just you use the formulation so you can easily make sure that everything is handled correctly and very well. So the next one is that we define a new integer value, integer variable. We call it val, and the number that is assigned to it is -5. Then, in order to have the absolute value of x, we simply can use this formula abs. Within the bracket, we put the name of the uh, integer variable that we defined. So let's compile and see what the result would be. We have no errors, it's compiling. Okay, now the absolute value is 5. You see? Here we assigned -5 and the absolute value is 5. So it is giving us the absolute value. It's a very straightforward library function that we can use in our code while we're doing the formulations. So the next one is we define a double called num, and we assign the number 4.3. And so in order to have the rounding up a number to an integer, the nearest integer to it, like rounding up to the nearest integer, would be using the cell function. So we say cell within the bracket num, it will give us the output of 5. So the output of 5 is expected to be seen here. Let's try and see what would happen. Yes, so here we see that the ceiling value is 5. So the value, the original number was 4.3, but the ceiling value is 5. It is rounding up to the nearest integer. Again, we can do this for like the other way. The other way around would be to round down a number. So to round down a number, we define another double called num2, and we assign the value 4.7, and instead we use the floor function. So instead we would use the floor function, and this time we are expecting to see the output as to be 4. Now compiling, no errors. Yes, the floor value equals 4. Let's check it out again here. Sorry. Let's check it out again here. Yeah, so the original number was 4.7 and the printed number is 4. So it rounded down the double number. So another function that would be very helpful for us in C++ would be the following. So if we have two numbers and we want to make sure what the result of what the larger number is among these two. So it's sometimes you might say that, okay, so if we know two numbers like 2 and 7, we already know that the larger number is 7. Yes, this is straightforward. However, in the day-to-day coding, you may define two integer values in the beginning of your code, like let's call them x and y. Then you do a lot of computation on these two values. And since the machine is handling all the computation, you don't know that x would be larger or y would be larger after like 100 lines of code being done for the calculation. And in the end, you just care about the larger number. So instead of, reading all those lines and going through the details, etc., you can simply use this library function. So in the end, you can simply just find fmax, the integer value for the first integer value, and comma the second integer value like here, and then it will just give you the largest value. So here we use fmax, and there are two values, 3.7, 3.5 and 7.2, and obviously the larger is 7.2, so you can easily get the larger number here. So this is the maximum, 7.2. As I mentioned, it may be straightforward, but when you automate everything in the code, like in tens of lines of code, in the end, you don't need to go through the details. You just simply use this function and it will return you the larger number. Hello everyone, welcome back to this course. In today's video, we're going to talk about how to read data from the terminal. So previously, we used to work with like this, like we would say int a equals 10, and then we learned how to print it. So the value of a is a and l. So previously we learned about this, so we compile. So compiling, no error. So here we see that it printed our data. So what if we want to read the data actually from the terminal? So if we want to do that, if we want to read the value a from the terminal, we should change our approach somehow. So we can change our approach like this. We just define our integer data type, like called a, and then we learn here a new syntax that is cin, and then we see in the a that we have here. But in order to read it from the user, we need to first show a cout message to the reader saying that, for example, whatever you want, you can say that tell me what your number is, and then we close it. Then we store the number that the user tell us. We store it here, and then we show it here. Let's try this program together to see if it works or not. So yeah, it says that tell me what your number is. So I would say 10, and it returns me the value saying that the value a is 10. So here we declared the integer, then we sent a message through the terminal to the user saying that, okay, tell me what your number is. And whatever the user enters here, it will be stored in the A using the cin syntax. And then here again with the cout syntax, we show what the stored and entered integer value was. So let's have some more examples here. So here again, I define another int. So let me comment the above lines so it's clear. So we have an integer value called number. We show the print value to the terminal, enter an integer, and we read the number, and then we show the number. So it's again the same procedure. We first declare the integer, we show the message, and then we store the number that is entered by the user, and then we show the output. So here again we compile. Let's see how it would work. So enter an integer. I would say 14 this time. It says you entered integer 14. So it stores it here. So the application of this is very widely known. For example, if you want to enter your panel through a website or where you have registered already, so you enter your for example, username for the first time and the password for the first time. So these two are stored in the database of the website using, if they're using C++, for example, one option could be using cin. So they store it in their database, and the next time that you want to visit the website or wherever that registration is, you enter everything and they check your entered data with their already stored database, and if it's there, they say okay, you can come in. There are some if conditions to check before they let you in that we'll discuss later on this course. So this is how integer is done. Then if we want to consider a character, so let me comment the ones that for integers here. So we have a clear code. So let's say I have a character defined that is char and the name is character. So that is char. You can call it whatever you want. Instead of that, I can say my char, for example. I would say this. So whatever you want, it's your call. So then we show the message to the user saying that enter a character, and then using cin function, we store it. And now here we have an error because we changed the name of the declared character. I would say my char. So, and then here we should have another error because we need to change the character here. So here what I'm doing is that I am declaring a character, then I'm showing again, I'm going through the procedure. I'm showing a message to the user saying that okay, enter your character. Then we store the character using cin function and we print it out. Okay. So for a character, we know that we need to store only one letter. So let's compile. We're compiling. Let's check it out. I would say R, and it returns me my character. Let's compile again. This time, for example, I would say A. It returns me the character again, A. So, but what if I want to put two letters like RE? It returns only R. What if I want to store more than one? Like I would say Reza. It only returns me R. Why? The reason is that we declare it as a char. So char only is able to store one letter, not more than that. So even if you write many letters there, it does not register it. It only is able to register the first letter. So this is something very important to keep in mind while you are using the characters. So what if we want to consider more than one letter? So then we don't have to use char or char, we are only using string. So in that term, let me comment these lines so everything is clear, so we know which lines are currently working. Let's go down. Yeah. So here we need to declare string. So when we want to use a string, we need to be careful to include this in the beginning of our code. So we did this already in another lesson. Here, string is included, so no worries. So we are calling the libraries of the C++ when we are including this. So, okay, we declare one string, the name is word. The name could be whatever you want. So here I name it as word. Again, the same procedure. We show a message to the user saying that enter a word and then store the word using cin function. And then we simply print it. So this time I compile. Let's see the result. No error. Okay. Enter a word. I would say Reza. This time, because we declared a string, it returns the full letters. It's not only the first letter like car. So let's try again. I would say whatever you want, like Amir Hossein. It returns Amir Hossein. Whatever you want. Let's try again. We say peer. It returns peer. One important point about the way that we are reading the information from the input is the following. So here I'm defining a string. I'm storing everything using cin function. So cin function cannot go after one space. What that means? That means it means that, for example, when we were having characters being stored, only the first letter could be stored. When we are having a string being stored using cin function can go up to no matter how many number of letters you have in your string, but there should be no space between them. If there are spaces between them, it cannot differentiate it. Let me just give you an example. So here we wrote Reza and Reza was okay. But if I push this space and then I write, for example, my last name, it returns me only the first part. So when we are using the cin function for storing the input, to read and store the input, it goes until the first string, and the second one is missed out because there is a space there. So, but if I compile again and write my first name and last name like this, it's okay. But there is no space here. Usually we put a space there. So what do we do? This is one of the problem using cin function. So let me just comment again. So here I'm commenting everything. So we go to the next lesson. So here I am declaring another string. I am couting, just enter 2 words or 3 words or whatever, and the full string, just whatever. But here I'm not reading the input as before. So before I was only using cin, but here I am using a get line and within bracket cin input. This helps us to read the entire line and not only the first word. Let's try this one. So if we try this one, let's see what happens. So if I write Reza, it will say Reza. Let's compile again. If I write Reza Shahin with a space, it gives me Reza Shahin with a space. And if I say like Reza Shaheen, it gives me the full line. So this is the one of the important things that we need to consider while reading the input. Depending on what we want to get from the user, we need to code based on that. Initially, we showed that an integer value can be declared, then a message sent to the user. We store it using cin, and then we show the message. We can do this with the characters, but only one letter can be stored in characters. So if we are aiming to get an information from the user that is one character, we use char because it uses less memory. But if it's more than one character and one letter, let's say, we need to use string. And if we want to use a string, if the string is only one word and no space there, so we can simply use cin function to read the data and store it. However, if there are multiple words, then there are some spaces between them, we need to use getLine instead of cin only. We use the function getLine, and within bracket you just type down cin input. This is some predefined function from the C++. And then you store it. Thank you very much for following this course. In the next lesson, we will dive into the deeper understanding of C++. See you there. Hi again, welcome back. Today, we're going to discuss if conditions. In the if conditions, there are certain things that we need to learn. But before that, let's review what we have learned so far. So we learned how to declare an integer number. Here we're declaring an integer called number. And then we print a cout syntax saying that we use cout syntax to print enter an integer. Then we learned how to store this entered integer by the user using cin syntax or cin function. So far, we learned how to do this. But now we're going to discuss the if conditions. So if conditions are like this. So imagine the user enters one number. And here we're saying that if the number is greater than 0, then print the number is positive. Else if, where we are having another condition. Else if, when we add another condition, we use else if. So else if in the bracket, number is lower than 0, so smaller than 0 in parentheses, cout the number is negative. And another else that we have is that if the number is neither than but greater than 0 nor smaller than 0, we have the else, the final else that says that, okay, the number is 0. So generally it's like if the number is greater than 0, it prints it's positive. If the number is lower than 0, it prints negative. And if neither of the conditions are met, it prints whatever that we want. We can say the number is 0, or we can say neither of the conditions met. So whatever. Else, it says that the above mentioned condition did not meet. So this is the else if. So let's run and try with a few more examples to see what happens. So no error, it's compiling now. Okay, enter an integer. I would say 10. So it prints the number is positive because 10 is greater than 0. Let's try it once more. So I would say minus 12. So the number is negative, so it works correctly. So if I mention something like 0, like here, it says neither of the conditions are met. So here the simple version of the if conditions. What we need to be careful about is how these if. So what is important is to know how these if conditions are written. So how basically they are written is that we have the if, then parentheses within which we write the condition. Like here, I say that if the number is greater or equal 90, then I put the brackets to have the conditions. One bracket is here and another one is here. If I'm going to check another if condition, this time we say else if. Then within the parentheses, we mention number is lower than 90, for example, and then we have the brackets, and then we see out the result. So in this situation, it is not efficient to have else. Why? The reason is that then a number is either greater or equal to 90 or lower than 90. So there is nothing that these two void conditions cannot meet. So this is why the else condition is not considered in this example. So if we want to run this code, it would be something like this. So we get the input from the user and we compile. Okay. Now that it is compiling, okay, it asks to enter one integer. I would say 94. So the result is your score is A. Let's run again. If I run again, this time I would type 75 and it says your score is not A. So if we test this code multiple times, either of these two statements will be printed. Like if I say 115, your score is A. So there is no condition that checks if the number is at the same time larger and smaller than certain value, so it pushes the number within a range. And also because, as I mentioned earlier, these two conditions are vastly considering everything that integer number can has there, so no else condition is required for this example. In other videos, in the continuing of this section, we are going to discuss some more coding exercises that help you to understand these concepts easily and grasp the meaning behind it. So you can you can put your hands on the keyboard and start coding to, little by little, by trial and error and following some instructions, you can get the meaning behind these if conditions. Stay tuned. Hello everyone, welcome back to another coding exercise session of this section. So in this coding exercise, we would like to write a program that shows if a number is odd or even. Before we start the coding, we need to think about the statement of the program itself first. So if we want to, so we can break it down. So if we want to see if a number is odd or even, so we need to declare firstly one integer or float. So preferably integer. Otherwise, if it's float, we need to first round up or round down the number to be an integer, then do the mathematical formulation on it, like the mathematical operations on it. So firstly, we declare it, we read it from the user, and then using cin function, we can store it in the declared integer. Then, so far, these are the things that we learned from the previous section. And then we need to start writing our if conditions statements that we learned in the current section. So let's dive in. Firstly, we declare an integer called number. We show the cout message to the user saying that enter an integer. Then we store the integer using cin function in the integer named number. So this is straightforward. This is the steps that we have been using. And as of here, we need to define the if condition. So the if condition, as you remember, it's if and within parentheses we write the condition, and then within brackets we write the statement that what do you want to do with the program if the condition is true, if the condition is okay, and if we enter the condition. And then we have the else, that the else does not need to have parentheses. However, if it's else if, we need to have the parentheses as we define the condition for the else if. But for the else, no definition is needed, because we are saying if this case is true, do this, and otherwise in any other case, whatever the case is, just print another message. So this is why else does not have the parentheses for any predefined condition. So here we say that, okay, we read a number from the user. If the number divided by 2 and its remainder equals 0. So in order to make sure that if it's equal 0, we need to use 2 equals sign. When we use 1 equal sign, it returns error, saying that because we want in the C++ programming language, when we use 1 equal sign, it means that we want to assign a number to one variable, to one data type. For example, previously, if you remember, we used to define int a equals 2. It means that at that time we were using only one equal sign. It means that the number 2 is assigned to integer a. However, here we are not saying that we want to assign 0 to something. We're just making sure if the number that we have here, that is divided by 2, and when we are using modula, it gives us the remainder of the division of number by 2. If this equals 0, so if it equals 0, we see the condition in the bracket. So in the bracket, we say that cout the number is even, because if a number is even, its remainder when it's divided by 2 must be 0. Otherwise, here we define else. Otherwise, the number is odd. So let's try it and see how it works. So I put a number like 20. It says the number is even, because if 20 is divided by 2, its remainder equals 0. So this is why the number is even is printed. So if 20 is divided by 2, its remainder that we are looking for using modula sign here equals 0. It enters this condition and prints the number is even. However, let's compile again. So what if I write 13? So the number is odd. So let's see how the program gets there. So we enter the number. It is stored in this data type called number. Then it goes for the first condition first. So it goes there. It says that, okay, number divided by 2, the remainder is what? Is it equal to 0? If it's equal to 0, it enters. However, in this case that we put a 13 when it's divided by 2, its remainder is for sure not 0. So it does not enter this condition, and it escapes this condition and goes for the else, because we said if this condition does not pass, whatever the condition is, enter into the else function. There it prints the number is odd. So let's try it once more. Like whatever the number is, like 101, the number is odd, because again it goes through the same procedure. Please make sure you practice these exercises before I start solving them. And also, when you see this video, when you watch this video and you understand the procedure, go use your own machine, use your own laptop, and try to implement this program several times. It helps you to get used to the syntaxes and how to write an if condition, for example. It looks easy, and it is indeed easy, but after several times of trying, it becomes easy for you. Welcome back to another lesson. In today's lesson, we're going to talk about ternary operator. The ternary operator is a shortened way to write an if-else statement in a single line. So it's a compact and efficient way to make simple decisions in code. The ternary operator is often used to simplify and shorten the conditional expressions. For example, here we see the condition we want to check. So we put it like here. The syntax looks something like this. So the condition that we want to check is this place. And then if this condition is true, the expression returns value if true. And otherwise, it returns value if false. And the question mark there separates the condition from the possible outcomes. So this is the condition. We separate it from the possible outcomes, and then we have the value if true and value if false. And colon here separates the value if true and the value if false. But how it works, we will see in a few seconds. Here, let's uncomment some code that we have. So, for example, previously we learned that if we want to understand if a number is even or odd, we need to write an if condition. Here I am initializing one integer value named number with number 5, and we are initializing one string named result. So we say that if the number is divided by 2 and its remainder equals to 0, so using the modulo sign we can find the remainder, and the remainder is 0, the result will return the even. However, if this condition is not correct, then the result it is assigned with the odd. So let's try and check it out. Compiling here, no error. Yes, so we have nothing in the output because we forgot to see out. Here is the output, and then we write result. So this is important to show the output result also. Okay, let's run again. So here is the output odd. So this is odd. Why? Because the number 5, when it is divided to 2, the remainder does not equal 0. So this is how we used to do it while we were writing the if conditions. However, if we are going to use ternary operators to write the same code, it will look something like this. So we ask the user to, for example, give us one number, and we store the result. Then here, instead of these lines about the if and else conditions checking, we simply write down the result equals, so we initialize the result as a string here directly. The result equals number, and here we write down the conditions. If you remember, I mentioned this conditions, question mark, and two possibilities separated by a colon here. So number, if it's divided by 2, its remainder equals to 0. So it is now separated with a question mark with the possible outcomes that are even and odd. So if this condition is true, it's going to print the first true value here. If this is not true, it will print us the odd value. So the odd value will be assigned to result if this condition is not correct. And if this condition is correct, even is going to be assigned to the result. So let's run the code and see. So if I say 10, it returns the value is even, the number is even. So there, let's go through the analyzing the code once more. So here the number is stored. We initialize a string called result, and its value equals to the condition of if this number is divided by 2, its remainder equals 0. If this is correct, the first condition is even, so even will be assigned to result. And if this condition is not correct, then this value, this result will be assigned to this result. Okay, so and they are separated by semicolon. And if you see, we simply could check the condition in one line here. However, we used to check it in like a few lines here, like 4 or 5 lines. So when we have a straightforward checking condition, it would be more efficient to use ternary operators. In the next lectures, we are going to practice some examples and coding exercises, so it will be more clear for you how it works. Hi, welcome back to another coding exercise. In the previous lesson, we discussed how we differentiate ternary operator with normal if-else condition statements. In this lesson, we are giving you another example. So here, the program, we want to write a program that says to check if a score is taken from the user and the number is something between 0 and 100. So if the number is larger, equal 50, return the pass. And if the number is not larger, equal 50, return fail. So previously, when we wanted to do that, we had to write if statement condition saying that if the score is larger, equal 50, go through the cout function and print pass, and else print fail. However, so it would take like 2-3 lines at least. So here we can write it down in one line. We initialize one integer. We show this to the user, and they enter their score, and we store their score. And we initialize this one string that is called result, and in the parentheses we mention the condition that we want to check, and this condition is separated from the possible outcomes using one question mark. So we write down the condition we want to check. If the score greater equal 50, then one option is pass, one option is fail. So these two possible outcomes are also separated with a colon. So if this condition is true, the first option will be assigned to result. And if this function, if this statement is false, then the fail is going to be assigned to result. And finally, we print the result here like this. So we will print like cout u and then the score and then the exam. So we would say you pass the exam or you fail the exam. So let's try this one to see how it works. So it says that enter one number. I would say 88. You pass the exam because 88 is greater than 50, and it returns, because this condition is true, it returns the first possible outcome. And if we try it more with another example, it will be like 30 and you failed the exam. Why? Because the first condition, the condition is not true. It's going to escape the first option and return the second option, and the second option is going to be assigned to result. Welcome back. In this lesson, we're going to have another coding exercise for ternary operator. So the question is asking us that to write a program that checks if someone is eligible to vote or not. If the person is 18 years old or above, the person can vote and the person is eligible for voting. Otherwise, the person is not eligible to vote. So we want to do this with ternary operator. So previously, when we wanted to do this with if else statement, we could define one if condition. So, and we would say if age is greater or equal to 18, we print eligible to vote. Otherwise, we print not eligible to vote. However, here in only one line, we can use ternary operator to do that. So the first we initialize an integer called age, then we ask the user, we store the input, and then we initialize one string called result here. We put the condition within the parentheses saying that if we don't write if, but the statement says that age equal greater 18. So if this condition is correct, the first output will be assigned to the result. And if this condition is not correct, the second output is going to be assigned to the result. And please note that the condition is separated from the potential outcome using a question mark. And also the potential outcomes are separated from each other using a colon here. And then we are going to print the result. So let's try and see how it works. Let's try. So now it's compiling and I would say 20. It says you're eligible to vote. Why? The reason is that the condition is true, so the first outcome is assigned to result. Let's try it once more. So when we try it again, we put for example, the number 15, and it says that you're not eligible to vote. Sorry. So this is how easy this ternary operator is. Keep practicing it, and where possible, you just use this condition instead of using if-else condition. Hello again. In today's lesson, we are going to discuss logical operators. So logical operators are used to combine or modify conditions in if and else if and other decision-making structure. So there are two main logical operators. There are other logical operators, but there are two main logical operators that we are going to discuss in today's lesson. So for the first one is the AND condition, and the second one is the OR condition. So the AND condition is when we want to modify two things. If you remember in previous exercises, when we were having else conditions and when we wanted if and else if conditions, when we wanted to check, for example, to see if a number is within a range, for example, to see if a number is between 10 and 20, we had to define one if condition saying that if the number is larger than 10, and in the statement of this if condition, as a nested if, we were adding another if, saying that okay, the first if is passed, the second if is to see if the number is smaller than 20. So something like this. Let me write it down. Something like this. We were like int a equals 22, for example. And we were checking to see if a is greater than 10. Then we were checking again if a is lower than 20, and then we were saying correct number in the output, something like this. You see, so there is one if condition here and another if condition here. However, using the AND condition, we can write these examples easier. So let's dive in. Let's see how it works. So for example, here, I would uncomment these lines to see how it works. So basically, we ask the user to enter their age, and if their age is above 18, and then we enter this state, these conditions of the if, and the statement consists of if and else itself, saying that, okay, now it's above 18, but if it's below 65, you are eligible to work. But if it's above 18 and it's not below 65, it's probably something like 66 and above, it says you're not in the working age range. And if this age is not above 18 initially, it says that you're not in the working age range. So let's compile this and see how it works. So this is if statement that we learned already. So I would say like 50, 60, sorry, and it says you're eligible to work. However, there are some ways to write this code in an easier way using logical operators. So it makes it more efficient and concise. So as you see, everything is about efficiency in the code to help having a better code. So here we are reading the age from the user and storing it. Instead of having two conditions, like one if here and another nested if here, we are only having one if here, saying that if age equals greater 18 and at the same time it is lower equal 65, then you write in the output that you're eligible to work. And the second logical operator is this. So we say else if, then we say if age is below 18 or using these signs, age is above 65, you're not eligible to work. So what are the differences between and or? So this is and this is or. So and if we are writing a condition statement using and, it must meet the condition before and the condition after and at the same time. So if both of these two conditions are passed, then we print these to the terminal. However, regarding the or condition here, or logical operator, if either of the conditions are met, we print this one. So this is the difference. Both conditions should be met here in the AND operator, but here either of these should be met. Let's try this program and see how it works. So, okay, let's say 18. It says you're not in the working range because so it checks here 80 is not in this range, and then it checks here, okay, 80 is passing one of the conditions, then directly goes to this place. So let's try another one. So I would say like 10, it says you're not in the working range again, because when it sees that the 10 is lower than 18, it directly prints that you're not in the working condition. So using logical operator will help us to have a more efficient and concise and shorter lines of code. It's nice to think of how you can make your code more efficient, and not just to write a code that works, but an efficient code that works perfectly in a shorter amount of time, in a lower number of lines to write the code and implement it. In the next lectures, we are going to practice some logical operators. Welcome back. Let's try some more coding exercises for logical operator. So we would like to write one program that checks to see if the number that is read from the user is divisible by both 3 and 5. So here we read the number from the user, we store it. Using logical operator, we check to see the number if it is divided by 3, and using modular sign we can see its remainder. So the remainder of the number divided by 3, is it equal to 0 or not? So if it equals 0, and at the same time when the number is divided by 5 its remainder equals both of these two conditions are true, then we print this to the terminal for the user. Otherwise we say that, okay, this number is not the number that we are looking for. So let's compile to see how it works. So for the AND logical operator, both of the conditions must be true. So if I mention 3, it says, no, your number is not divisible by both 3 and 5. Why? When 3 is divided by 3, okay, the remainder equals 0. However, for this case, for the second condition, it doesn't work. Let's try another number. So if I put 5 here, again, we have the same message here. It says that, okay, this is not divisible because the second condition is correct because the number is 5. So 5 divided by 5, the remainder would be 0. However, for the first condition, it's not true, it's not correct. Therefore, it escapes this if condition and directly goes to the else and print the outcome that the number is not divisible by both 3 and 5. So let's try another number. I would say 15 this time, and this time it says that, okay, the number is the number that we are looking for. Because 15 divided by 3, its remainder would be 0, and the same goes with this statement, this if condition, saying that if 15 is divided by 5, its remainder equals 0. Therefore, this statement is printed in the output. As you see, working with logical logical operator helps us to write a more efficient code. It would be nice a priori to writing a program, think about it deeply to see how we can integrate these features that are there for us to make our code more efficient and more advanced and concise. Hello everyone, welcome back to another lesson. Today we are going to discuss about Boolean flags and how they can be integrated in our if statement conditions and if else conditions. So previously we learned about logical operators. For example, here we initialize one integer, we read the score from the user and then store it. And then using AND logical operators, we check if the number is above 50 and lower than 100, then we print out the you pass the quiz and otherwise you fail. So this we learned previously. Let's try and see this one. So for example, I would say if my score is 76, it says you pass the quiz. It's very straightforward. We discussed this already. However, if we integrate Boolean flags into this if-else condition, it gives a descriptive name to the condition, making the purpose of the if statement clear and easier to understand when the code is shared with others. And also, they can help keep track of whether something has happened or a specific state has been reached in your program or not. So therefore, they can help us to reduce the error as well, because we don't have to repeat certain complex, logic repeatedly. So let me give you an example. I will comment this part, and then I will do the same. I will rewrite the same code, however, using the Boolean flags. So instead of only initializing the integer, I am also here initializing a Boolean data type that is called past quiz. So here initially I put it to false. It's your call, but usually when we want to use the Boolean flags, we initialize them to a false value, and then when the condition is met, we set it to true. So initially, by default, they usually are false. So here we show the message to the user saying that enter your score, and then we store it. Here we mention that if the score is above 50 and less than 100, using AND logical operator just like before. If this is the case, don't right away print, okay, you passed the exam. Set the Boolean flag to true instead of false. That was by default initialized. So set it to true. And if this is the case, set it to true. So we don't have to write the else condition. So we are avoiding writing this else condition. We are just writing one if condition. So if this happens, the condition is passed, therefore the passed quiz boolean is set to true. Then in the end, we can check this condition saying that if passed quiz equals true, then you pass the exam, and else or otherwise you failed. Let's try this one. So it's compiling. Now I would say 75, and it returns pass. Why? Let's analyze the code. Here it checks the number with these conditions. It passes and then set true to passed quiz, and then because the passed quiz equals true, it prints that you passed the exam. Also, this part is redundant. We can also remove this. So by default, when we use a Boolean flag, so when we write no conditions for them, it means that if they are true, it's like that. So let's compile again. So we can eliminate that part as I mentioned. So now I would say 87, and it prints you passed the quiz. So easily, you don't even have to mention that it equals, if it equals true. The fact that you put the Boolean flag there without anything, it means that, okay, if this is true, this is something by default known by the C++ compiler. So this way you can avoid the second else and let the decision be made only with this one. And of course, you need to add another if conditions to print out your result, but this way you are making your code to be more readable. So its readability is increased, and it is very common among programmers to use Boolean flag because it gives a description to your if condition. So this if condition is defined because we want to make sure if the person is passed or not. However, here, okay, after reading the code, we understand that yes, this if condition is defined because we want to check if the guy is passing the test or not. However, it is only showing a message saying that, but in this place, we are assigning true to past quiz. So you see the difference is that this code is more readable, it reduces the error, and helps to increase the readability of your code. Thank you for watching. In next lectures, we are going to practice a little bit if statements with Boolean flags. Welcome back. Today we are going to do some coding exercises regarding the Boolean flag. So the program is asking that write a program that checks using Boolean flag if a user wants to continue or not. So for example, I don't know, you're playing a game or something like that, and the program will ask you, do you want to continue playing or not? So if you want to continue playing, you should push the button yes, otherwise no. And depending on your choice, the reaction of the system would be different. Here, we are going to do that using Boolean flags. So we initialize a character called choice and a Boolean flag named wants to continue. And we initialize it to false. As I mentioned, it's by default. We use it to false. If it's true, we then set the true to it. So we show the message to the user, do you want to continue? Yes or no? So the choice is stored using cin function, and it's a character, so it only can get y or n. Then we write an if condition saying that if the choice equals y, then set true for the wants to continue boolean that was by default set to false. So when the user says yes and says y, the true is assigned to wants to continue. We don't print anything up to here, okay? We don't print any results, let's say, because previously we were printing the message to the user through the terminal. Then we check if wants to continue, you chose to continue, else you chose not to continue. And as we discussed in the previous video, we don't need to write down equal true, for example, for wants to continue. By default, when we write down the boolean in the if condition, it is considered by default by the compiler that you're saying like if this is true. So even if you don't write equals true, it understands like you were writing if this is true, if this equals true, for example, something like this. So let's try it out and see how it works. So I would say why it says you chose to continue. Let's analyze the code once more. So I said why, it then set true to wants to continue, and it says, okay, if wants to continue equals true, then you print you chose to continue. Otherwise, you chose not to continue. Let's try again. I would say N, it says you chose not to continue. You chose not to continue. So as we mentioned here, it helps to have a better code and a meaningful code saying that giving a meaning to the if statement of your code by using Boolean flag. And little by little, when you get to more advanced level and start reading other people's code, usually programmers that are in higher levels, they use Boolean because it gives it gives some meaning to the if else conditions, because when you read this code, the programmer, the reader who knows C++ would understand that, okay, the aim behind writing this if condition was to see if the user mentioned yes or no, rather than just printing a message and showing the result, okay? Because this is something we show here to we showed to you to see it so you can have understanding and to see how the output would change depending on the input. But usually when, for example, we have a program like the game that I mentioned earlier, if you say you want to continue, you probably get back to the game and continue playing. And if you say no, you probably get out of the game and exit the game. So these messages usually do not show in the terminal and actions are being done behind the scene. But we are just printing these things to show how the input can make the difference in on the output, how they can have impact on the output rather than just showing the messages. So the reason behind showing the messages is this, so you can understand the procedure and how changing in the input can impact the output. So as I explained, Boolean flags are very important to be used. So think about them and start using them little by little in your practices and exercises. Thank you for watching. Welcome back to another coding exercise session. Today we are going to do some further exercises for the Boolean flags. So we want to write a program that checks if a number is even or odd using Boolean flags. So we initialize a number here and then we initialize a Boolean called isEven equals false by default. Then we get the input from the user, we store it, and we say if the number modulo 2 means that if the number is divided by 2 and its remainder using modulo sign equals 0, then set true for isEven Boolean that was initially set to false. And then if isEven is true, then print the number is even, else the number is odd. Let's try it. It's 20. Yeah, the number is even. Let's try once more. 21. The number is odd. So here, I think after having a few coding exercises and seeing a few examples, you realize the importance of using if flag, Boolean flag, and in the if statements, showing that how useful it can be, and you will understand the logic behind it after doing a little bit of exercises, and you will see that okay, it is making my program looks better, more advanced, and more less encounter to any errors and repetition. Thank you for watching. Hello everyone, welcome to another lesson. Today we are going to talk about switch function. So the switch statement is a control structure used in C++ to simplify decision making when dealing with multiple conditions. So it is an efficient and readable alternative to using multiple if-else statements, especially when we have several potential outcomes. So it helps us to have a more organized code and more clearly handling outputs when we have like several of them. So let's start with an example. Here we used if-else conditions. We say, okay, we initialize the integer called day with the value of 3. Then we say if day equals 1, print Monday. If it equals 2, print Tuesday, etc. until the end, until if day equals 7, print Sunday. And else invalid input. So all of them, the first one is if, the other ones are else if until the end. If neither of the above conditions are correct, just print invalid day. So let's try this code and see how it works. So it is printing Wednesday because we mentioned the day equals 3, then 3 here, and we are printing the Wednesday. But as you can see here, we're checking many conditions, and it's really hard to go through all these lines because there are many conditions to be checked. Instead of doing this, we can use switch condition. But let's first discuss how switch condition structure would be. So instead of saying if, we write switch, and then we write down the variable in the parentheses. Then we open the bracket And when we open the bracket, we check the case with the first condition, again case, second condition, case with the third condition, and then as a default, it is exactly working like else. So if neither of the above mentioned cases were there, we use the default. When we write down the case, we write down the conditions, we put semicolon, and we go to the next line, and we execute the code whatever we want, and then we must write down break. So the program exit when enters this statement after executing whatever it needs to execute, it breaks. Otherwise, it also goes for the next case, and it also goes for the next case. So it is important for us to manually break it. So let's do the example. It would be more clear how it works. So let me uncomment these lines, and then we run the code that we have here. So already when looking at this code and comparing it with this code, you see that even it looks nicer. There are some spaces between them, and you can read it much easier. So we say the input is day and it is set to 3, and instead of if, we write down switch and we put the day. So the day is our variable that we are trying to check some conditions over this variable. Then instead of having multiple if else if conditions, we are just mentioning case, 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 case until the end. So if case, instead of saying if day equals 1, we say case 1. It means if day equals 1. But instead of writing all of those things, we say case 1, case 2, case 3. It means that when our case, which is day here, equals 1, equals 2, equals 3. But we don't write those things. This is why it makes the program much easier. And then we have the semicolon, we go to next line, and we say, okay, if you enter this condition, print Monday. If you enter this condition, print Tuesday, etc. until the end. And we need to remember, we don't have to forget this break. We need to write down the break at the end of each case. And there is, instead of having the else after having all of these cases, we have a default here saying that if neither of the above things happened, if none of them were true, so you just simply print out invalid day number. So let's try and see how it works. It is printing again Wednesday, so it's much straightforward, and it is more readable as compared to using if conditions. So when we have a lot of conditions to be checked, it's easier to use a switch statement. So as you see here in this course, I'm giving you different tools, and I'm teaching you different tools that are used in C++. And based on what you want to do, based on the application of your code, you need to wisely choose these tools. So you can use if conditions until forever, and you can use it always. But is it efficient? No. Probably there are some cases that you need to write it with Boolean flags, you need to write it with switch statement, etc. So these are only toolboxes that I'm offering, and depending on your application, you need to first clearly think about all of these tools and see how using these tools and when using these tools would be beneficial for you to write a more concise and efficient code. Welcome back. In this lesson, we are going to use a switch statement once more to see its application and to see how it would be easier to work with switch statements in some cases when we have a lot of conditions to check. So here we need to write a code that asks for three things: two numbers and one character. So based on the characters that we're going to choose between addition, subtraction, multiplication, and division, the program is going to execute one of these operations on the two numbers that we are going to give it as an input. So we initialize the character and two numbers, then we read and store the character, we read and store the numbers. One thing to mention here is that previously we were reading and storing the numbers one by one, but here we are doing another method. So we mentioned that enter two numbers and we stored them simultaneously. So when I enter the first number, it will be stored in the num1, and then when I enter the second number, it will be automatically stored in num2. Then we have the switch statement here. Our variable is operation, so depending on what operation the user is going to choose in the terminal, we need to do different things. So the if condition, previously, if we wanted to write the if condition, we would have checked if operation equals addition, equals subtraction, multiplication, etc. However, here we are not using that method, so we are writing switch and the variable is operation. So in case that it is addition, we just print out the result saying that result, and then we have the addition here, and then we break. So in case we have the subtraction, we have the colon, next line, result, subtraction, and then the break. So don't forget that the operation is defined as a character. So we need to have these quotations before and after our math operations. And if it's a star, it's multiplication. And if it's division, this is the nice place here to discuss some reviews for the if condition. So if it's division, enter here, and then we have one if condition that is nested in our last case. So, and then we mention if num2 does not equal 0, then num1 divided by num2 just show the result. However, if num2 equals 0, we need to write then an error because no number can be divided by 0 based on math. And then when these two if and else conditions are checked, we simply break, and the default is like the else condition in the if statement. So if neither of these above mentioned operations are entered, we just mention invalid operation. So let's try it out to see how it works. So I would say addition, first number 2 I enter, and then second number I put it and I enter again. So it is storing both numbers and returns us the addition of these two numbers. Let's go through the code once more. So it stores two numbers simultaneously. It enters this switch part. In case that in case that the user chooses to have the addition, it enters this place and then it gives us the result as shown here. Thank you for watching. Don't forget to practice this switch statement more and more so you get used to it and know when to use it efficiently. Hello everyone, welcome to another coding exercise lesson here. So today we want to write a program that depends on the input. It gives us different messages in the output. So we would like to write a program that prints stop if the input is R, prints get ready to stop if the input is Y, and go if the input is G. and also returns invalid color if neither of the above mentioned cases were given as the input. So to do that, we can simply use if else condition. However, because we have many cases, like 4 cases to discuss, it would be easier and more efficient to write switch condition. So we define a light color character here. We get it from the input. We show the message to the user, enter traffic light color, R for red, Y for yellow, and G for green. And then we store it. Then we have our switch statement, and we are going to check the conditions on light color. Therefore, our variable is light color. And in different cases, we discuss the different cases here. So we say if it equals R, we don't write them down, but when we write case, quotation mark R means if light color equals quotation mark R. Colon, we enter this statement and we say cout stop. And then we need to remember that don't forget to write the break there. And in the case it's Y, get ready to stop, it need to be printed. And in the last case, which is G, you can print go. In the default case, when neither of the above mentioned cases were true, we mention invalid color. So let's try it and see how it works. I would say G. It says go. I would say this time, I would say Y. It says get ready to stop. So let's analyze the code once together. So here it starts here, checks the R, saying that light color, does it equal R? No. Does it equal Y? Yes. So when it's not equal R, it escapes. Then it goes for the case Y, and then it is correct. It's true. Then it enters here, and then when it breaks, everything is exited. So the program stopped right there when you put the break. And in case we write something different, like if I say like D, it says invalid color. So because it checked 3 colors, input colors like R, Y, and G, and neither of them were there. So it went to the default statement saying that invalid color. So you see how it is easy to use switch statement instead of if else statement when we have many conditions to check. Hello everyone, welcome back. Today we are going to talk about for loops. So there are different types of loops that we can go over, a certain data type, and for example lists, strings, etc. Iterate over them. However, today we are focusing on for loops specifically. But in this section, we are going to discuss different for loops as well. So, for example, imagine that we would like to print a few numbers, and it would be very hard to do it easily. Like, for example, I could say cout number 1 and del. So I want to write, like, imagine that I would like to print number 1 to 5. So I need to do it 5 times. So I modify this. I put 5 here. I put 4 here. So now I need to print this one. So let's compile and see. So yeah, here you see when I want to print 5 numbers, I need to write it down 5 times. Okay, but for 5 times it may be still okay. But what if it's 500 times? It would be very hard to, track the changes, to modify everything. and at least copy paste it. Even copy pasting it for 500 times, it's not easy job. So there are other ways to do it, and in programming, you something that can give us the best and most efficient way of coding. So in order to do that, we need to use loops generally. And today I'm going to tell you how to use for loops to do that. So imagine from number 0 to number 4. To do that, we come up with a for function. We have parentheses within which there are three main components in this parenthesis. So in the first component, we initialize integer as to be whatever the initial number of loop would like to be. So here in our case, we integer named I that starts from 0. Then we have semicolon separating the first part from the second. We have this I until it reads like this I until it is smaller than 5, not smaller equal than 5, only smaller than 5. Then semicolon saying I plus plus, and I plus plus means that the increment value of I. I'm going to discuss this in a few seconds. So for these are the three components of a for loop in parentheses, and then we start the loop actually as of here. So as of here, we start going through the loop saying that cout I, we print I, so we understand the value of I. It's a printing in the terminal, so it makes more, it increases the readability of the code, and then we print the actual value of the I. But how does it work? Let's see. So first we start from I equals 0. When we start from I equals 0, we enter this loop, we mention I semicolon, then we print the value 0. Then after that, we increase one time the value I. So initially we entered the loop with the I equals 0. We printed the value 0 using this line. And when everything is finished here, it goes back again into this, but because we have incremental value of I is now equal 1, and then with the value 1 it again enters this loop and prints 1 for us here. It iterates until it reaches to this condition, so until it is smaller than 5. So it iterates until it is 4. When it's 4, it breaks and we exit the loop. So let's try and see how it works. So now we're compiling. Okay. So here, as you see, it starts with the value 0. It prints I semicolon 1 space 0. Then it goes up again and enters the loop with value 1. It prints I semicolon, I colon space 1, and then it is incremented again, and it does this iteratively until I reaches 4. When I reaches 4, it enters one more time to the loop saying that cout I colon space print 4, and then when it incremented to the value of 5, it does not satisfy the second part of our for loop, so it does not enter again and it finishes the loop. So this is how we can print something like 5 times. Even if we want, we can say like instead of 5 we can put like 20. So whatever the number that we would like, we just put it here and it will just go for it. Let's see. Yeah. So here it starts from 0 to 19. And if we want to print number 20 as well, we can say smaller equal 20, and instead we could say, for example, let's start from 1 this time. So let's see. Okay, great. So we started from 1 and we're printing until 20. So generally, this is one of the most efficient way of printing iteratively instead of just printing everything manually. And in next lectures, we're going to solve some exercises and do some coding exercises to understand it better. So generally, the important thing is that we write the for, we have parentheses within which three parts needs to be filled, and then we enter the loop. Hello everyone, welcome to another session. Today we are going to do some coding exercises using for loops. We are going to write a program that prints even numbers from 1 to 10. To do that, we start right away with the for loop. So we start right away with the for loop and we open the parentheses. And here there are three parts to respect. The first one, we initialize one, for example, here integer value equals 1. And we set the upper bound for our integer value here because we want to start from 1 and go up to 10. We say smaller equal 10, and we have the incremental value saying that okay, first 1, then increase it one time, then increase it another time. So we use incremental values for that. When we finish three parts of the for loop condition in the parentheses, we enter the for loop actually. Here, because we only would like to print the even numbers, we write one if condition here. So we say if this I is divided by 2 and its remainder equals 0, then cout I. Otherwise, we don't want it. So else we don't write it because we don't want to print anything in the loop because it is going to be printed for those that don't have the remainder equal to 0. So let's print this one and see how it works. Yeah. So it starts from 1. 1 comes here and 1 is divided by 2. Its remainder equals 0. No, so it does not do anything. And then it goes and comes back with 2. 2 divided by 2, its remainder equals 0. Then 2 is printed, and then 3 comes here. And when 3 comes here, 3 divided by 2, its remainder is not 0. And then it is doing nothing and it's printing nothing. And it goes until it reaches the last number. So iteratively it goes up. And here we could, like, for example, we could write something like else, and then here cout I, like this part here. So here, if I do this, it is going to print 1 3 5 because 1 3 5 7 9, basically all the odd numbers, because odd numbers are not going to pass this loop. They're not going to pass this condition, the first condition. They're going to be in the second condition. So let's compile this one, see how it works. Yeah, so it is printing everything now, and it's hard to distinguish the result. This is why here we avoid using else condition. We just want the ones that are having the remainder equals to 0 to be printed. And if we wanted to, for example, print the numbers that are odd, we could write like this. So if I divided by 2, its remainder does not equal 0. This is going to print us all the odd numbers. So let's try. So it's compiling. Okay, great. So here, for example, I is divided by 2, its remainder does not equal 0, then it is printed. Then for second, for number two, I gets the value equals 2. It enters 2 is divided by 2, its remainder equals 0 actually, and it does not enter this loop now. And then it prints nothing. Then I is incremented one more time. Now its value is 3. 3 divided by 2, its remainder does not equal 0. Then it enters the if condition and it prints the value. So this is how it works, and generally we can play with it like if we want to print all the odd numbers between 1 and 100, so it's easy to do it, but manually doing that, it takes a lot of time. So here we see that, yeah, it is printing almost, not almost, but all the odd numbers that are between 1 and 100. So this is one example, very small example, very easy example of how important the for loops are. However, we will see in other levels like intermediate and advanced level that we use these loops very frequently to do very advanced tasks. For example, if you want to find a maximum, the maximum number in a list of numbers. So we do iteratively, we go through all the elements of that list, for example, and then we write some coding there to find the maximum number in a list, for example, or the minimum number, and then we want to do some mathematical operations for that maximum number, etc. So these are very useful, especially if we are going through a lot of data, a list with a lot of inputs, for example, a lot of elements. So imagine that there are like 1000 elements in one list and you would like to find the maximum number. Manually doing that, it would be very hard and it takes a lot of time, it increases the error, etc. But doing programming, this is why we are programming. In fact, it can give us the result very fast. Hello everyone, welcome back. In this session, we are going to do another coding exercises. Here we are writing a program that calculates the sum of numbers from 1 to 5. So to do that, we can do it manually, which is the hard way. The easy way is to use for loops. So we initialize sum as to be 0. Then we start a for loop right away. And it has three parts, as you know. So because we are calculating the sum of numbers from 1 to 5, it starts with 1 and its upper bound is 5, and it is incrementing one step at a time. So and since sum equals 0, it is initialized to be 0. Here we have 0 equal 0 plus 1 in the first iteration. So I equals 1. So 1 is assigned to sum. Then it goes up again, I equals 2, and it enters the loop again. So I equals 2 here, and plus sum was 1 from the previous iteration. And the sum of these two will be 3, and 3 is assigned to sum now. So it goes until I equals 5. When it equals 5, it enters for the last time. It does some calculation here, and then the loop is finished. And the final value of sum is printed here. So also I put one line here so we can iteratively see the increase in the value of sum. So let's see how it works. Okay, so as I mentioned here, the first one is sum is 0 and I is 1, so 1 is assigned to sum. Then I is 2, sum is 1, they are 3, and 3 is assigned to sum for the second round. For the third round, it will be 6. For the fourth round, it is 10. And for the last round, it is 15. The last round is stored in the sum for the final number because we're not going to enter the loop anymore, and then we print the value of sum here. So one of the ways to do some of these calculation is using for loops to make it easier. It is always possible to do everything manually, but we're coding to, increase the speed and have more efficiency, etc. So one point here is that now we are saying sum equals sum plus I. So even for this, we could write our code even more simpler and more efficient. So writing it like this, sum plus equal I is exactly like writing sum equals sum plus I. So we could use either way. So let's try uh, this one and see if there is any difference or not. So there shouldn't be. Yes. So as you see, the results are the same. So the results are the same, and it's only the matter of how you would like to code. Usually in advanced programmers are using this method because it's more concise. So if you see something like this, it means that sum equals sum plus I, but it is a more concise way of writing it. Hello everyone, welcome back. Today we're going to talk about another way to write loops. And here in this lesson, after finishing the for loops in a previous lesson, we're going to focus on while loops or while conditions. So there are different types of loops that we can employ to write certain number of blocks to print certain number of blocks and execute certain number of codes. And one of them was for loops, and the other one is while loop. So here the structure of a while loop would be like we say while and then the condition, and then we enter the executive part. And this is the place where we write down our code. So let's start with an example. I think it would be easier to grasp the idea when we make an example. So here previously we used to go through the for loop. So if we want to write a number to write a program that prints us number 1 to 5, we had to write like for loops, something like this. Let me just type it down. Int I equals 1, I equal smaller equal 5, I plus plus. And then we could say, okay, print I and del. So this is how we used to print number 1 to 5 previously. However, if we want to do the same thing but using while loop, we can break down these three parts of the for loop into different parts. So first we initialize the integer number named num as to be 1, and then we start the while loop. So we start the while loop, and in the parentheses we only write down one part of the condition, which is as long as num smaller equal 5. So the condition would be something like this. So we repeat the while as long as num is smaller, less than or equal 5. Then we enter the loop. So we print out the num, and here we are incrementing the value of num ourselves. So previously we used to put this part in the parentheses, but we are putting the uh, increment part inside the loop. And previously we used to initialize the integer in the parentheses, and we are initializing it before the loop. And then we are printing the the num using this cout function. And also the second part of the parentheses for the for loops is exactly printed here. So the reason why we may need to use, for example, while loops to execute our code is because a while loop in C++ is it can help us to repeatedly execute a block of code, like similar to the for loop. However, the while loop is more straightforward and often is used when the number of iteration is not known beforehand. So when we don't know how many iteration do we need, we simply use a while loop and we say as long as the num less than or equal 5, just do this for us, and then change the value of num so we can increase it or decrease it as we want to see in this line. However, if we forget to write this part, it will become like an infinite loop because it is printing, for example, num equals 1, it enters the loop, it prints 1, and then it prints 1, and then it prints 1 forever until we stop the program because 1 is not being increased. So when we increase the value by 1 here, then the next time that it enters the loop, it's 2, then it's 3, etc. So let me just run the program and see how it works. Okay. So yeah. So here num equals 1, and when we want to go through the condition of the while loop, we say, okay, num equals 1. Num is less than or equal 5. Yeah, it passed the conditions. It enters the loop. It prints 1. Then it increased the value of num by 1. So num would be 2. Then it comes here again and checks the condition. 2 less than or equal 5. Yes, enter, print, and then increased. So now it's 3. 3 smaller or equal 5, yes, enter, increase, it will be 4, and then again until it's 5. When it's 5, it enters for the last time, and when we increase the value, it will become 6, and 6 is not less than or equal 5, so therefore it does not enter this loop again, and the program is finished. So this is how while loop would work, and in the next sessions, we are going to do some coding exercises using while loops, so it would be easier for you to see it in different examples and start making it understood for yourself and start coding it yourself. Thanks for watching. Hello everyone, welcome back. Now we're going to do some coding exercises using while loop. We would like to write a program that works like a calculator to adds up whatever we give it as an input, and it's going to work as long as we are adding a new numbers, except if we put 0, it will stop. So for example, I would like to add a few numbers and know the sum of all of these numbers. So I keep entering new numbers, and if I mention if I put 0 as one of the numbers, the program knows that I would like to finish the input numbers, and it returns me the result. So for this program, we need to write a while loop. We cannot write it using a for loop because we don't know how many numbers the user would like to give us so that we can do the calculation for him. So as long as the user is giving us any number, we're going to store the number, and when he or she gives us the number 0, we consider it as a sign to that he is done with entering the numbers. So we do the final mathematical addition for him or her and return the person the result. So let's see how it works. I think when we run the code, we can understand it a bit easier. It's easier to understand. So we initialize one number called number, we initialize another integer called sum. we set sum to be 0, and then we tell the user enter numbers to add and 0 to stop. So if the person enters 0, the program is going to be stopped. However, any other number to be entered by the user means that the user would like to add these numbers. So the number is read from the user using cin function. So we write a while loop here. So the while loop would be like this. The condition is like as long as the number is not equal 0. So continue until user enters 0. As long as the user is not entering 0, enter this loop. We enter the loop. We assign the number to sum, store it in the sum, and then we ask again from the user to give us the new number that the person would like to add up to the previous number. So let's try it once. It's easier to grasp the idea. So I mention, okay, enter numbers to add. I say 1, I enter, nothing happens. I say 2, I enter, nothing happens. I say another 2, nothing happens. Now I put 0. So now it's done. When I put 0, it gives me the final sum. So 1 plus 2 plus 2 would be 5. And when I put 0, the program is finished, because here we are mentioning that enter this while as long as number does not equal 0. So when I put 0, it cannot pass this condition, and it simply prints out the sum. And how is it printing the sum? So let me remind you of this. So we learned that this line would be, so what we have in line 181 here equals this line. So instead of writing this, they wrote this. So let me just show you how the program worked in my example. So initially I mentioned the number to be 1, 2, 2. Okay. So initially I said number equals 1. Then I mentioned number equals 2. Then I mentioned number equals 2 again. So it starts with this. So the sum is 0. It says sum equals 0 plus 1. Then sum equals 1 plus 2. Why? Because, so initially the sum equals 0 because we initialize it to be 0. And we enter the number to be 1 in the first round, and 1 plus 0 is 1. So 1 is assigned to sum. So then it goes for the next round. So as for this equation, sum equals 1 from the previous iteration. So the value of sum is 1 here, plus number. So as the second input, I put 2. Then the value would be 3. And then the equation would be 3 because 3 was the final value of sum from previous iteration. And in the new iteration, so the sum is 3 plus I mentioned the another 2, so the sum would be 5. It's exactly how it is computing this sum here. So 1, 2, 2, and then when I put 0, it exits the program. Let's try it once more. So so it's basically working like a calculator. If I say 1, 15, 18, 20, and then 0, it computes everything for us. So 20 plus 15 will be 35 plus 18 and 1 will be 54. So this is how our calculator is working here. When we smash the 0 button, it exit the program. And this is actually one of the usefulness of while loop. So we don't know how many input the user can give us. So it is customized. So one user can use it for 2 times, one user can put it for 10 times, whatever they want. And when they are done, they can put 0. Of course, we could do it using for loops as well. Using for loops, there were some ideas to say that, okay, we are going to ask you a bunch of numbers that you would like to add. Please first tell us how many numbers you want to add initially, be a priori. So that we could do in a for loop as well, but it's much easier to do it using while loop. So this is actually why while loop is there. Thanks for watching. Don't forget to exercise these coding exercises yourself. Hello everyone, welcome back. Welcome to another coding exercise. Today we are going to write a program that counts down a number from 10 until 0 and prints the value one by one as it is decreasing. To do that, we use while loop here in this example. So we initialize countdown integer as to be 10, and then we mention while the countdown is greater than 0, enter this condition, and first print the countdown for us and then reduce its value by 1. So then next round the countdown number will be 9. It prints 9, it reduces the value to 8, then another time 8 is still bigger than 0, it enters the loop and it prints the 8 and then it reduces the value. So let me run and then we analyze the code once together. So here, as you see, it says 10, 9, 8 until 1 and then lift off. So this is how the program works, as you see here. So 10 is the initial value. Is 10 greater than 0? Yes, it enters. It prints 10 here. Then it reduces the value of 10 by 1. So now the countdown equals 9. It comes back here. 9 greater than 0. Yes, enter. Print 9. Reduce the countdown value by another 1 value. Will be 8. So 8 greater than 0. It prints 8. It reduces the value again by 1. It will be 7 now. 7 greater than 0, prints 7 and reduce it by another 1 value. So we continue until it's 1. So 1 greater than 0, see out 1, we print the 1 and we reduce the value of countdown by 1, which will be 0. So 0 greater than 0, no. So it does not pass this condition. It will not go through the while loop anymore. And it says lift off. So this is how while loop would work. So we can increase and decrease the value in the loop. So previously, if you remember, we had 3 conditions for loops. We used to have like for int equals I int I equals 1, I smaller than 10, for example, I plus plus, and in this situation, do something, for example. It is notable to consider this. So this int I part is written here, for example. This second part condition is written in parentheses for the while loop, and this last part, the incremental part or decremental part, is written within and inside the while loop. So this is the only thing that we need to be careful about. Otherwise, it's very straightforward and it's good for you to start practicing and coding hands-on programming so you can get to know these little things and these little steps to make errors and learn from your errors. Thanks for watching. Hello. So today we are going to discuss another way to write loops. It is do while. So it is very similar to while loops, but there are certain differences. So a do while loop in C++ is similar to a while loop, but with one crucial difference. A do while loop will execute the block of code at least once, even if the condition is false, on the first check. So this is because the condition is checked after the code has run and not before. So the main advantage of a do while loop is that it ensures the code block runs at least once, no matter what. So this can be useful when we want to ensure the user interacts with your program, or when you need a certain action to take place at least once before checking a condition. So it's often used in programs that require user input because you typically want to prompt the user at least once before deciding if you need to loop again or not. So this is basically how it works, and generally we start the structure would be, we say do, and in the brackets we execute the code, and we say while, and then we put the condition. So let's see an example here. So we initialize one integer called number, and then we say do, we open the bracket, we say enter a positive number. We store the positive number that the user enters, and we check. So if the number is lower or equal 0, we say that's not a positive number. Please try again. And then it comes here. So the condition is that if the number is lower or equal than 0, lower than or equal 0. So it repeats until the time the user gives a positive number. So to say it in an easy way, it would be like this. It asks me to give a positive number. So if I enter a positive number, the loop will finish, and then it prints out this line saying that thank you, you entered, and enter and print whatever we entered. Or if I give it a negative number, it enters this if condition. For example, I would say -2. So if I say -2, it is for sure lower than 0. It says, okay, that's not a positive number, try again. And while the number is -2, go back to this part again, enter a positive number, and then we store the number, and then it sees if it's positive or negative. If it is negative, it repeats everything again. So let's try and see how it works. So enter a positive number. I would say -20. That's not a positive number. Please try again. So -25. Enter again. It says that's not a positive number. Please try again and enter a positive number. -30. It will not finish as long as I'm giving a negative number. And when I say like 20, it says thank you, you entered 20. So this is how generally a do while situation, a do while loop would work. So I entered 20, it stored, I firstly entered -20, it stored -20. -20 is lower than 0, yes, so it prints this value and it says, okay, while -20 is lower than 0, go back to the do. So it starts from here again, enter a positive number. And we entered -25 here. It says -25 lower than 0. Okay, it showed this message and saying that okay, 25 is lower than 0, go back to the top. So it goes back and to the top again and again and again until I enter a positive number, which is the case here. And then it says thank you, you entered 20. So this is basically how a do while loop would work. It is being executed first, as we mentioned, Then the condition will be checked to see if another execution of code is required or not. So if I was going to, oops, sorry, what did I do? Yeah, so if I was going to, enter like a positive number in the initial iteration, like if I say enter a positive number and if I say 11, it says thank you, you entered 11. So I say enter a positive number, it says okay, the number is 11. Number is 11 is not lower than 0, then it escapes. It's not lower than 0 again, it escapes. So the loop is not going to be executed anymore, and it says thank you, you entered like 11. So it is one time executed and then the condition is checked here. So this is the main difference. Hello and welcome back. Today we are going to give you a coding exercise using do-while loop, so you see how practical this do-while loop is. So we are going to write a program that checks to see if you're entering your password correctly or not. As long as you're not entering your password correctly, it is going to ask you enter the password again and again and until it is correct. So when you enter the correct password, it finishes the program. So initially we initialize two strings, one password and one corrected password. So imagine that the correct password is ABC, something very easy. And we start our loop here, do, so it enters the loop without checking any conditions. It says enter the password and you enter your password. It says if the password is correct, it does not enter this condition because this condition says that password does not equal the correct password. So if the entered password, the one that you enter, is not equal to the correct password, that is ABC, it says enter incorrect password, try again. And it says as long as the entered password does not equal the correct password, ask this again from the user. And if by chance you mention that, okay, enter the password and you enter the password and the password equals correct password, it does not enter this if, it escapes, and here the condition does not pass because the password equals the correct password, so it does not have to go another time in the loop, and it says access granted. So let's try and see. So if I say ABC, it says access granted. So here is my password. Here is the correct password, ABC. Enter the password. I say ABC. So ABC, it says that password does not equal correct password, but this is not our case because the entered password and the correct password are the same. So it escapes this loop. Then it checks to see as long as password does not equal the correct password. So this is not also our case because they are equal. Therefore, it finishes the loop and it gives us the access. However, let's try once more, and it says like enter the password. I would say something like this. It says incorrect password, try again. I would say anything, try again, try again. And whatever you enter, it says try again. And in the end, I mentioned the correct password and it says, okay, access granted. So you see, this is very useful example, and this is a very practical example in the real world. We have some access like that in the world when we want to check something like emails, etc. Of course, there is a limit until like you can repeat it for 2 times, 3 times. After that, your account will be blocked for security reasons. However, we can use the do while to do that. So here it says enter the password. I say QWE. It says they are not equal. Therefore, it enters this if and prints incorrect password. And because they are not equal, like the entered password and the correct password are not equal, it goes to the loop once more. It says enter the password and it stores, and I said TRTY, they're not equal. It says incorrect password, try again. So it is what it is printed here. And then because they're not equal, it goes again to the loop. So this continues until I give the correct password in the end, and it says access granted. Hello everyone, welcome back. In today's lesson, we are going to talk about nested loop. So a nested loop is simply a loop inside another loop. This means that you have one loop running within the body of another loop. So the outer loop runs a specific number of times, and for each iteration of the outer loop, the inner loop runs completely. So imagine a clock. So the hour hand is like the outer loop, and the minute hand is like the inner loop. So for every movement of the hour hands, which is the outer loop, the minute hand inner loop completes a full cycle. So another way to visualize this is to think about a grid of rows and columns. So the outer loop iterates through the rows, and the inner loop iterates through the columns. So in order to make it more clear, let's come up with an example. So here, just imagine that we would like to write a program that generates a 5 to 5 multiplication table. So we have rows and columns here, and we want to see this in the output. How to see this in the output? Previously, we learned about how to do for loop, but when we were doing for loop, it was like 1, 2, 3, 4, 5. So, and that's it, or 1, 2, 3, 4, 5. So it was not like a full table. So I would like to write a program that generates a 5 to 5 multiplication table and shows something like this. To do that, the outer loop is defined like int I equals 1, I smaller than or equal 5, and I plus plus, and then we enter the loop here. And then we have the the inner loop, we have the int j equals 1, j lower than or equal 5, and j plus plus. And then we see out I times j. So let's run first the program. So exactly as we want it. So exactly as we want it, we have like 1, 2, 3, 4, 5, 2, 4, 6, 8, 10. But how does it work? So let's analyze the code a bit so we can understand how it works. So here we enter the loop with I equals 1, then j equals 1. So when I equals 1 and j equals 1, I times j would be 1. Then still here we had the I equals 1, j equals 1. So and it's finished now. We did the calculation and we printed 1 here like this, and we also put it here. Then j is increased by 1 value while the I stays the same, because we didn't finish this loop first to go back and increment the value of I. So I stays the same, and then j increases. So the first result was I times j equals 1. Okay, so now I still equals 1 while j equals 2. Now I times j equals 2. Another round. I still equals 1 and j increases until it reaches 5. I equals 1, j equals 3. Then we have I times j equals 3. And this continues until we have I equals 1 and j equals 5, therefore I times j equals 5. So when we reach this stage, it's the first line being printed. Yeah. So it means that this j started from 1 and reached to 5. Okay, so it reached to 5. Now it has to get out of this inner loop. When it gets out of this inner loop, we print out cout and l. So it is here now when the j loop finishes, and it goes to the next line here. And when it goes to the next line here, please note that it is in the first loop still. It goes up. So now the value of I increased from 1 to 2. So now we have I equals 2, j equals 1 again, and I times j equals 2 as to have here, as we have it like here. So, and then I stays 2 until j is 1, 2, 3, 4, 5, and when j reaches 5, it again finishes the inner loop and it goes to the next line using this end L function. It is here, it goes to the next line, which will be here. So now I is incremented from 2 to 3. So then it does the calculation again. So this is basically how inner loops would work, and it's a very nice way to make when we have two-dimensional arrays, lists, numbers, etc. We can use nested loops, and they are very convenient to work with, and they are very practical. So I would suggest you to practice this nested loop example as much as you can. So, and you start, if you forget what I told you about the analyzing this part, it would be nice to go back and review these analyzes and then start doing the coding yourself. And then when you forgot, you either can come back to this video or you can start doing the analyzes yourself to understand the logic behind it. It would be very important, I guess. And then move on to the next coding exercises. Thank you for watching. Hello everyone, welcome back. Today we're going to do another coding exercise here. So we would like to write a program that prints a pattern of numbers in the form below. So this is the form that we would like to print. So in order to print something like this, we usually don't know it by heart. We need to think about it. So this is where the programs get a bit more complex than before, and we need to start thinking about how to get to the result that we want a priori to start just right away coding the program. So in order to print that, we can use a nested loop. To do that, we have one outer loop and one inner loop. So in order to have these two loops, we first start with the outer loop, that is I. We say, so let me first run the program so we see that we have the result and then we analyze it. Okay. So here we have the result as we wanted. So, but how did we get there? And with only 3 lines of code. So how did we get there? Let's analyze the code. So first we have the outer loop, which says integer I equals 1, I lower than or equal 5, I plus plus. Then, so this is not something very strange. This we have. This we already had in many examples. So here we also have this for int j equals 1. However, the upper bound of j is I. So j must be lower than or equal I, and then we increment its value one step at a time. And then we print the value j. When the first loop, the inner loop is finished, we go to next line and then we go to the outer loop again. So how does it work? Let's see. Let's start writing the output here step by step. It would be easier to understand the logic. So first I equals 1, we enter the loop. J equals 1, and at the same time j must be lower than equal I. So an I is 1, so j must be lower equal 1. So only one iteration for j is allowed because it already starts from 1 and it must be lower than or equal to 1. So when it enters I equal 1, j equal 1, and the result would be 1. So it prints the value of 1 like this because we are having C out j. Then it goes here, so the inner loop is finished. It goes here, it goes to the next line. This is where the first one is printed, and then it's go to the next line. Now I equals 2. I equals 2, j again equals 1 because it starts from 1 every time. And j must be lower than or equal to I, which will be something like this. So j will be lower than or equal to because the value of I is 2 this time. So given this, we will first start with j1. So with j1, the inner loop is executed, so it prints 1. So the first result will be 1. And then it goes to the inner loop again. It increments the value of j, and j will become 2. 2 is still lower than or equal to as the condition here, so it enters the loop again and prints the value 2. So it prints 2. When it prints 2, it reached its maximum level, so it reached its upper bound, which is equal to I. So I is 2 and it reached 2, so it's finished. So the inner loop is finished. It prints it does one handle, so it goes to the next line here and starts from here. So now it goes to the first outer loop. So now I equals 3 and j starts from 1 again, and as j has to be lower than or equal to I, it means that j must be lower than or equal to 3. So j starts from 1, 1 enters the inner loop, and we print 1. Then we increment the value of j. J is 2 now. 2 is lower than or equal to 3. So yes, it comes here again and prints the value 2. And another time j is increased, and then now the value of j is 3. 3 is passing this condition, so 3 lower than or equal to 3, yes, so it comes here again and prints the value of j. So now that j is 3, it reached like this, like it's like writing 3 lower than equal to 3. So it does not it's not able to go another round, because if it goes for j equals 4, it does not pass this condition here. So because of that, the inner loop is finished. It goes to the next line using this part of the code. So, and it goes to this part. So as you see here, this one here, we reached here. Then we have this one, which is here. Then we have 1, 2, 3, which is here. And then next time when the inner loop is done, it comes here. It goes to the next line. We were here, it goes to the next line. So now we are here with this line, and then it has the outer loop. So it goes back up again. So I was 3, we increase the value of 3, it will be 4 now. 4 is lower than or equal than 5. Yes, pass the condition, enters here. So enters the inner loop. So I equals 4, j equals 1. So j must be lower than or equal to I, because in the second part of the for loop this condition applies, and then it means that because I equals 4, it means that j must be lower than or equal to 4. To do that, j equals 1 starts the loop while I is 4. So it's like writing 4 here for this time, for this round of iteration only. So j equals 1, it prints 1, and then it comes back to this line. Okay, it increased the value of j and then prints 2, then comes back to this line, increase the value of j, print 3, and then 4. When it reaches 4, it means that j is equal to its upper bound, then it cannot continue. So that it cannot continue, it finishes the inner loop, and by having this line, we are now here. After this line, it goes to the next line, and then we have the outer loop. So the outer loop is still I, which is 4. Now we increase the value of I from 4 to 5, which is the last time, because I also must be lower than or equal to 5. So this is the last round that we enter. So we enter with I value 5, I equals 5, while j equals 1. And it starts from the j equals 1 again. So j has to be lower than or equal to I, means that j has to be lower than or equal to 5. So it enters with j equals 1. So it prints 1 time, and then increase the value of j, come back here, it prints the value 2, 3, 4, and finally 5, and it cannot go beyond 5, because when j is 5, it is reaching its maximum level, which is 5, and then it goes to the next line. So from there we go to the next line, but we do not go back to the outer loop anymore, because also when the value of I is 5, we increase it to 6. It does not pass this condition, so it cannot enter the loop again. So this is how this nested loop would work. So let's run one more time. Yes, so you see how this nested loop has worked, and how we got to the printed form and pattern of the numbers that we were looking for here. It is very important to start practicing these things yourself, because it's little by little it is getting a bit more complex. So in order to make sure that you are improving your coding skills as you're proceeding through the course, please try these practices yourself several times. This is very important. Thank you for watching. Hello everyone, welcome back to another lesson. In today's lesson, we are going to do another coding exercises using nested loops. However, before we dive in, if you haven't had the chance to rate this course yet, I kindly encourage you to take a moment to do so. So your feedback is incredibly valuable in helping us improve and ensure the future learners have the best possible experience. So thank you for sharing your thoughts and rating this course. So now let's move on to our next coding exercise. Here we would like to write a program that prints a 4 times 6 a rectangular of asterisks. So what we would like to be printed would be something like this. So we have 4 rows and we have 6 columns here. We would like to print that, and we need to use a nested loop to do so. So the outer loop would have four range, like I starts from 1 and we'll go up until 4 because we would like to have 4 rows here, and as the statement mentions. And then as we would like to have 6 columns, we are having the inner loop to range from 1 to 6. So we start from here. Let's run the code first and see how it works, and then we will start analyzing the code. Okay, so now we see that we have 4 rows and 6 columns. So let's analyze the code. So initially here I equals 1, enter the loop. So it checks to see if I equals 1 and it's lower than 4, I plus plus. So I equals 1, enter the outer loop. And when we enter the inner loop, so j is equal to 1. So I would say I equal 1, j equal 1. Then when j equals 1 in the first round, it says print 1 asterisk. So it prints 1 asterisk. Then the inner loop is finished one time and it goes back again. So it increased the value of j from 1 to 2, and it comes back here and it prints 1 asterisk for us. Then j j was 2. Now we increase the value of j by another value, and j becomes a 3. Then 1 asterisk is also printed here. It continues until j equals 6, and we print another asterisk here. So it would be like 6 asterisks would be printed, because when j equals 1, it prints 1, then it's 2, another asterisk, then j is 3, another asterisk, then j is 4, 5, and 6, another asterisk. So the range of the j will, depending on the range of the j, we are going to print asterisks here. So we have the value of from 1, j equals to 1, and j lower than or equals to 6. So 1, 2, 3, 4, 5, 6, we are going to have 6 asterisks being printed, because this is how the range tells us. So when j reaches its upper bound, the inner loop is finished. When the inner loop is finished, we finish this column. We have the endl syntax here. So like it's like here, we printed 6 asterisks. Now we are here, we have one endl, which will force the program to go to the next line here. So when we go to the next line, we go back to the outer loop where I was 1 initially. Now we increase the value of I by 1 and I becomes 2. I equals 2, and j starts from 1 to 6. And because of that, we will have another 6 asterisks being printed, because when j equals 1, it enters the loop, print 1 asterisk. Then j is increased to the value of 2. Then another asterisk is printed here until j reaches its maximum level. So then when j reaches 6 again, we finish the inner loop and we go to the next line. We are here. When the second inner loop is finished, we go until here because of endl, and we have the outer loop. So in the outer loop, I now equals to 3, and the same logic goes for I equals 4. So basically, if you would like to have like 4 rows, we have the upper bound, we have the range of I from 1 to 4. And if we would like to have 6 columns, we need to have the j or the inner loop has to be from 1 to 6. If we would like to have 8 columns, we can simply say j starts from 1 and it's going to be lower than or equal 8, for example. So this way we are going to have 8 columns here. So let's try and see how it works. Let's see. Yeah. So here, as you see, 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 columns here now because we mentioned we would like it to go up until 8. And if we would like to have, for example, only 2 rows, we can change the range of I and say it starts from 1 and it's going to go up until 2. So let's compile again. So yeah, here we see that now we are having only 2 columns. So depending on what we would like to have as columns and as number of columns and rows, we can change these numbers. And also now we are printing asterisks. So we can print whatever we want. For example, we can print addition. So let's try this one. We can print additions, or we can simply print we can simply print I times j, or whatever that we want. So it depends on what we would like to print. So now it's going to give us the value of I times j every time. So there is a, oh, sorry, I need to put this sign here. I forgot. Okay. So when we compile now, okay. So here we see that it is printing the values of I times j. Like for example, I equals 1 and j equals 1, so it prints 1. Then I is still 1, but j is now 2 because the value of j is increasing from 1 to 8 now. So then 2 times 1, here we have it, then 3 times 1 we have it, then 4 times 1, etc. Then we finish the inner loop, the first inner loop, and we go for the second loop. So we go for the incremented value of the I, which is the second iteration of the outer loop. So I equals 2, now we have I equals 2, and when I equals 2, j equals 1, we have 2. When I equals 2, j equals 2, we have 4. When I equals 2, j equals 3, we have 6, etc. until we reach the I equals 2, j equals 8, which will, the result will be 16. So if we would like to have like now 4 columns, we can also try this like that. So here, if you would like to have like 4 columns, we see that the 4 columns is shown like, sorry, 4 rows. So 4 rows are added. So I equals 4 here, j equals 1, so the result would be 4 until it gets here to the last number where it is the, you see the last row means that the last iteration of the outer loop, so I would be equal to 4, and it is the last column, so columns are not very organized, but this is the last column, so it means that the j also equals its largest value, which is 8. So 8 times 4 would be 32. So in order to have a matrix, for example, of numbers, we know that we can use nested loops, and also the number of rows depend on the outer loop and the number of columns depends on the inner loop. Hello everyone, welcome back. Today we are going to talk about functions. So in this lesson, we're going to talk about functions. So a function is like a mini program within your main program. So it is a reusable block of code that performs a specific task. Instead of writing the same code repeatedly, we can put that code in a function and just call it whenever we need it. So we write it once, we write the function once, and we can use it multiple times. So it saves the time and effort. So if you have a program that calculates, for example, the sum of two numbers in multiple places of your code, using a function avoids writing the same code again and again. So the program will become easier to understand and to maintain, of course. And functions break down, the complexity tasks, the complex tasks into smaller, manageable pieces. So, for example, here, if you remember previously, we were talking about like printing one thing here, like saying uh, the sum is, and then the number and L. So let me just initialize two numbers saying that int a equals 10 and int b equals 12, for example. And we are saying that the sum is a plus b, okay? So using these three lines, we can have the sum of a and b. However, just imagine that we have like 1000 lines and this code continues like for many times, and we have different blocks of codes here. Just imagine here we have a lot of codes and different tasks to be performed, and at some point again we would like to add two other numbers, like we would like to write down int c equals, for example, 15, and int d equals 20, for example. And then we see out the sum of c and d is c plus d and l. So you see, we are repeating this calculation again, and we had it one time here, and then we are repeating it here, and we may need to repeat it several times. So instead of writing these many codes repeatedly, we can simply just define a function to do the job for us. In order to define a function, we need to first declare it a priori to our main function. So this is our main function. So any C++ program will have a main function. Everything is within that main function. So before this main function, we can declare our additional functions that we would like to have. For example, here we declare a function called add, and it has two values as input values, int a and int b. So within the parentheses, it shows how many input it can take and what are the types of the input that it can take. So the first type is int a, so the first type is int and the second type is int. So the input of the function called add are two integers, and here this int shows the output of this function. So basically we learned 3 points here. So this is the name of the function, and within the parentheses we learn how many inputs the function has and what are the types of the inputs. In this case, they are both integers. It could be one integer, one float, it could be anything. And the third point that we learned here is that the output of this function, the resulting of this function would be also an integer. So we declare the function right here. So we are just saying the name, the output, and the inputs, and a semicolon, okay? Then when we come here in the main function, we call the function like this. So if we call the function, now within this int main function, we can call add. Why? Because initially, a priori to this main function, we have defined the function, okay? So we must define it before the int main. So when we call it within the int main, so it recognizes it and it does not return an error. However, this function is just declared here. In order to know what this function do, now I close the int main function. We go through the details of the function here. So basically, it would be something like this. We declare the function, we use the function. However, after the int main function is finished, we write down the details of the functionality of that function. So in order to do that, to see what this function is doing, we come to the end of the code. We exactly write what we wrote already for its declaration. Instead, we don't have a semicolon in the end, and we have two brackets within which we define the function. So every function has inputs and outputs. Here in our case, we have two inputs that are integers. And the output would be the value of a plus b. So this could be a plus b, or it could be like c plus d, whatever the input of the function is, it can add it. So basically we are saying if the input is a and b, so you return those gathered inputs. So this will return the value of this function. So we write down return and we do the addition here. So this is how this function would work, and we go up to the main function. So I summarize it one more time before I go into more details. We declare the function before the int main function. We define the function after the int main function and say what it is going to do. And it must have one return value. So it usually has either a return value or it's a void function. So void function, we will talk about it in a few seconds or in a few minutes. But in this case, because it's not a void, if it was void here, instead of int, we had void. So it's not a void function. It's a normal function that returns an integer value. To return this integer value, we write down return and we do whatever we want to do here. So and then we want to use this function in the main function, in the main block of code. So we define one int result and its value is this. So this is how we call the function. If you remember, the function name was add. So it's going to call the function named add with two values, 5 and 3. And when it is going to call this function with 5 and 3, it's like saying that, okay, one input is 5, the other input is 3. So it's going to add 5 to 3 and it is returning its result, which is 8. So 8 is returned and assigned to the result. And now we are printing the value of result. Let me just compile it once. Okay, so now we see that the sum is 8. As we discussed, here we call the function with two inputs. So if we are saying the inputs are integer, they must be integer here as well. It's not like that we can declare them as integer and we can put like 5.2 and 3. It returns error. So they must be integer. So then 5 and 2 are called using add function, and 5 plus 2 plus 3, sorry, it will be 8, and 8 will be returned here as the number assigned to the result. So instead of, for example, adding the different integers and different parameters throughout the code again and again and again, so we don't need to write it anymore. We just, whenever we want to use it, we just call the function. So let me just do another thing. I would say int result 2 equals add, like we can say 10 and 2, for example. It's not possible to write 10 and 2.2. There will be a problem if we run the program. So, and then I see out the second sum is, and I print the value result 2 and del. So let me just compile this. Yeah. So here we see we didn't have to do the calculation anymore. We just call the function once more with new values. So you can call the function millions of times, and with new values you can do the calculation. However, the function is written only one time. So it is more efficient to have functions that do the job for you, so you don't have to call them one by one. So this is very important to keep in mind to use the functions. And another thing that we could do here is like the following. So as you see here, we are printing the sum is in the main block. In order to be super efficient, we can also mention that in this function we define a new integer called c that is equal to a plus b, and then we see out the sum is, and we print c every time. So here what we can do is like this. So let me just clear this part, and this and this. Let me see if I have errors or not. Okay, great. So you see, even now the code is even more clear. So here we are only saying add 5 and 3, add 10 and 2. So this is going to add any two numbers that are called using the add name, because the name of our function is like this. And this function now, it is actually not returning anything. So we can change the function to void. So what is void? Void, we change the function output, we put it void, and we forget about this. Let me just first run to see. Okay, great. So here, previously, we were doing the calculation directly. We were saying return a plus b. However, then we decided, and then the return value was being assigned to the result here. However, then we decided to not to assign these function values to any integer, and we do all the calculation in the function. So the code, the main block will be more clear. Therefore, we do the calculation here and we print everything here. So we are not printing anything here. So a void function is a function that is going to return no value. It's only doing some calculation. So now I change the integer output to a void value, to a void function, because it's not returning any value. It is simply just doing some calculation and printing something. If it is going to return something, it has to have some output data type like integer, float, double, etc. However, if it's not specifically returning something like this, like a plus b, for example, if it does not have something like this, it's a void function that is doing some calculation for us. So this was a brief introduction of the functions. In next lectures, we are going to do some coding exercises. Thanks for watching. Hello everyone, welcome back. Today we are going to do some coding exercises. So we would like to write a program that writes a function that greets everyone who is running the program. To do that, we could simply write down cout and write the message that we would like to have, like welcome here, and del. However, in the main function that we have in C++, we don't want to write anything like that, and we would like to only have codes that are calling the functions and tasks are done in the functions. Therefore, the code is more clean, more readable, and more understanding. So to do that, we define one void function here. So the name of the function is greet. It has no input. So let's see how it works. Before starting the int main, we learned that before that we need to declare the function, and we have the option of defining the function either after the int main or even before the int main. So in this case, I am declaring and defining a function, both of them, both tasks before the int main. So I will learn three things about functions. So this will be, the name is just something that is behind the parenthesis, just before the parenthesis. So the name is greet. Whatever that is in the parentheses is the input of the function, and whatever is just before the name is the output. So as the input, it has no input, so we don't need to put any input when we want to call it. So it's not like add function like addition, so we give two numbers, so it will do some mathematical operations with those inputs. It's just a simple greeting function, so it needs no input. Whenever we call it like this, it's going to be performed, and the output is void. Why? Because it is returning no value. So as you can see here, we are not writing return something here. Okay, as we are not writing that, this function is a void function. Whenever a function is returning a certain output, it is not a void function. But here we are doing nothing. So let's compile. Okay, now we see that the function is working very well. So instead of writing cout welcome to C++ and do some additions, do other things in the main part, we're just calling the function greet. So the code is very clean, and everything is done behind the scene. So this makes you to have a very good understanding of how the code work chronologically. So when you have, for example, 10 functions, from the beginning, you start, for example, greet, you go and read the function greet, and you come back here. Okay, the first step was greet. and then the second function is here, third, fourth, etc. So whenever you want to see the details of each function, you go and read that function. And in the main menu, in the main function, everything is clear and only the functions are there. And all the details or the works, all of the coding details and all of the works are within each function, uh, making the code to be more understanding and clear for the reader to see, okay, there are 10 functions here. If I want to read about the greet function, I click on the greet. So I can simply and easily navigate the greet function. Otherwise, I have to, look for every line to see where we are greeting when we are greeting the customers, for example, etc. So this is another example for greeting. In the next session, we are going to do some more coding exercises. Hello everyone, welcome back. After discussing the definition and the declaration and the details of a function that we need to keep that in mind, the next topic that we're going to talk in today's session is about local and global variables. So a local variable is a variable defined inside a function or a block and is only accessible within that function or block. So once the function or block is done executing, the variable is destroyed and its value is no longer available. This is a definition of a local variable. And when we are talking about a global variable, we define it like it is defined like outside of all functions, usually at the top of the program, and can be assessed and modified by any function in the program. So it's important to differentiate these two concepts. In order to explain this, we brought you an example here. Let's recall how a function works and then we dive into this example. So we need to define a function. We need to declare a function before the main function that we know from before. In parentheses are the input of the function. In this case, it's empty, so there is no input. And before the name of the function, we have the output of the function. So the output of this function is void, so it's not going to return anything. These we already know from previous lessons. So then after declaration, we need to define the function. We have two options for this. Either it can be defined where it is declared like before the int main function, or it can be defined after the int main function. So we had the examples of both situations in previous lessons. So here I'm going to declare it before the int main function, and I'm going to define it also there before the int main function. So what it's going to do is that in the int main, so the program, when we run the program, only the int main function is going to be executed. And if I'm calling a function within the int main function, that function that is called is going to be executed. For example, if I simply remove this line, nothing is going to be executed because we didn't call the function so it can be executed. So it's an important thing to know. Because the function is declared and defined here, it doesn't mean that it's going to be executed. If you want it to be executed, you need to call it in the main function. Otherwise, it wouldn't just work. Let's try. We will see. You see, nothing is being executed because we are not calling anything. So it's important to call whatever function you're just trying to use, call it after declaration and definition. So we are just calling here the display function. And when we execute the code, it's going to come here, and then within that function, in that parenthesis, in that bracket, we have the definition of the function. So in the definition of the function, we are initializing one integer value called local num, and it is equal to 10. And then we are printing this value local num. Okay, so this local num is a local variable. Let me just change the name, maybe it would be confusing. I would say int x, for example. Okay, it's going to, so the number is, okay, so this x variable that is an integer is a local variable to this function. Okay, why? Because it is declared and initialized in this function. So it makes sense that it's not accessible from here. Why? Because it is not initialized and declared here. So what the program would see if we want to use something in the int main function, what it would see is the only thing that are here. And since it is not here, this integer value is not defined in here, it is a local variable for this function. We can have another, let me just add another function here. So I would say num2, and I define y and it is equal to 20, and it is okay. Now we have one main function, and then we have one void function and another void function. So we can have like tens of hundreds of functions, so it doesn't matter. So this integer that is called y and it is initialized and set to 20 is a local variable to this function, and this y is not accessible neither in this function nor in the main function. So it's a local variable, so it makes sense. And also for this x is neither accessible in here nor here. So let me just run. Here in the int main, we are calling the display number. So display number is this function. We are assigning 10 to integer x, and then we are printing it. So it is printing x. However, if we are trying to like print x directly here, it is expected to have some errors. You see, even we cannot even run it. We have error here. So why? Because it says use of undeclared identifier. It makes sense because x is defined here, so it's a local variable for this function and not for the main function. So this is the concept of local variable. In the next video, I'm going to talk about the global variables. Hello everyone, welcome back. In this session, we are going to talk about global variables. Previously, we talked about local variables, and we mentioned that local variables are defined within each function and only are accessible in that specific function. So if we have function number 1 and we define integer x, it is only accessible in function number 1 and not in function number 2 or int main function. So here we are going to discuss global variables. I have one int main variable here and one function here and a global variable here. So the global variable here, as you see, it is in none of the functions. So this is why it is variable. So this is the first function. This is the second function. So, and this variable is defined globally because it is not inside any specific function. Therefore, it can be used in any function. So, because it can be used in any function, in int main function, I'm going to print its value, its initial value. Okay. So let me just run this code. So as you know, whatever that is inside the int main function is going to be executed, nothing else. So if we are not going to call this function, right now because we commented it, it's not going to call this function. This function is only going to be working if I call it in the int main function. So let's compile and see how the program would work only with this one line. Okay, so here we see that it says global number initially 100. So it says global number initially, this is the message we type, and then we print the value of global num. So the global num equals 100. It is printing it easily and it is accessible because it's a global number. So then we have the option of modifying that global number. So in order to do some modification and mathematical operations in this global number, we define a void function here. So a void function is defined before the int main. The input is empty and it is void, so it returns nothing. So basically in this function, when we call this function, we are going to add 50 value to its original value. So if you remember, when we have global num plus equal a number, it means that we are having like global num plus 50. Okay, so whatever the value of global num is, it is added with 50, and then its summation is going to be assigned to the global num. So in this case it is 100 and it is 50, so the new value is 50. But for the sake of efficiency, we simply write it like that. So it's the same thing. So get used to also using equations like this. So we call this function here. This function is going to add 50 value to the original value of global num, and then it's going to print global num inside function, saying that global num, and then it is going to print this value. And here we have like global number after modification, and it is going to call this number again. So we are going to have three prints. Why? Firstly, in the int main function, I'm going to call global number initially, and this number is this number which is global, so it is accessible here. And then I'm going to call this function. This function is going to add 50 values to the original value of global num, which was originally 100. So therefore it is now 150. And it's going to also print the global number inside function message and also print the new value of global number. So previously it was 100. Now we modified this number and it is 150. So because it's a global number and it is now 150, we are printing it again, global number after modification. So we expect to see 150 here as well. So this is a global number done once in the int main, done once in this function, and also called again and used again in the int main. It is a very good example showing that how one global number is accessible from anywhere in the code. So let's compile and see how it works, and then we analyze the code. Okay, so let's analyze. So we have the global num here 100. When we call it initially in the main function, it says global num 100. So it is printing its value here. Then we are calling this function using this call. It is going to add 50 values to the global num, and it is going to print its new value as to be 150. Then when the work with this function is finished, the code is going to come back here and goes to the new line. So now it's going to print cout global number after modification, and it's going to print global num. And it's going to give us the 150. So we see that we can access the global number from anywhere. So let me just add something here. If we have another void function, modify to, for example, I would say, and then we are saying global num minus equal 100, and then we are going to cout the global num inside the second modified function is, then we have the global num handle. Okay, so and then I'm going to also call this new function tool. Sorry, the name is not correct. So whenever we are calling the function, even if it doesn't have any input, it's important to have the brackets, to have the parentheses. Sorry. So with this new defined function, we are going to subtract 100 values from the global number. So we had like 100 here, then we call this, and then it adds 50 values. So here it is 150. Then this function is done, where the program goes back to the main function and it is going to print 150. And then we are calling this second function. So the second function is going to reduce 100 value from the global num. So let's execute the code. Okay. So on top of what happened so far, we said that 100, 150, and 150 again. But here, I modified the global number once more. So once more, I call a new function that is going to subtract 100 value from the last modified value for the global number. So it is going to simply do the modification like 150 minus 100, it will be 50, and it's going to show the result for us. So this is one thing. So this is what we need to know about the local and global variables. But another point to show the efficiency of functions is that here you see we are having two functions being called, and these are the things that I added simply because I wanted to have a better explanation of the code. These two lines can be also removed, but here and here we are just calling the functions and all the work is being done here. So if someone wants to read our code, it would be very easy for the reader to understand what we're doing here. So this is why we say we need to use functions to make the int main function as clear as possible. Thank you for watching. If you haven't had the chance to rate the course so far, please go ahead and do so. And also don't forget to give us your feedback. It would be valuable for us to improve the courses for future students. Thank you. Hello everyone, welcome back. Today we're going to do some coding exercises regarding the local and global variables. We would like to write a program that declares a global variable to store a counter. So the program should have two functions. One increment counter, and this function should increment the counter by 1. And we have the main function, of course, which calls the increment counter function twice and displays the updated counter value each time. So now we know that we need to have a global variable. We need to declare a global variable then we need to have one function here and one function here. And so the main function is going to call the other function twice, and the other function needs to increment the counter or the global function by one value. So to do that, we start by declaring the global function. We know that from before the global function, the global variable should be declared above the code and outside of any function. So this is the global function xy, we name it and we initialize it to be 0. Then here we have the main function, and here is the increment counter function. In order to have a review, we know that a function has three associated data with it. So when we are declaring it, so now here it's the name of the function. Before the name is either void or the output of the function. So here, if it was instead of void, we had integer. We knew that the function should give us an integer value in the end, and so it returns one integer value. But because this function is returning nothing, we have the void function. And also within the parentheses, we will have the input variables of the function. So in this case, we have no input function, so we can just call the function without giving any input to it. So, and this is how we declare and define a function. And we know that we must declare the function a priori to the main function. However, for definition of a function in this part, we can do it either before the main function or after the main function. So it's up to you. Here, I'm declaring and defining at the same place before the main function. And here, what it's going to do is that it's going to get this xy and increment its current value by 1. So, and we learned that plus equal something means something like this. So instead of plus equal, we could write xy plus 1. So this equation here is exactly like this equation. So it says that whatever the value of x is, or xy is already, add 1 to it and assign it to xy again. So here xy is initially 0, and when we increment it by one value, we add one value to it, its final value will be 1. And then if we do it another time, its value will be 2, etc. And here we are having the main function. In the main function, we firstly learned whatever that is in the main function is going to be executed. So if we have a function here and it is declared and defined, but it is not called in the main function, it is not going to be executed. So here we are firstly printing the initial counter xy. So we expect to see value 0 in the output because initially the global variable number is 0. Then we call the increment counter as it was asked here 2 times. So we mention increment counter and increment counter. So in the first round, let me just type it like this. In the first round, it will be something like this. xy equals xy plus 1. So for the first call, it will be like xy equals 0 plus 1 because its initial value will be 0 and we are incrementing it by one value. So the final value would be 1. For the second call, xy equals 1 plus 1, which will be 2. Why? Because initially it was 0. Then in the first call, we increase its value by 1, so it's 1 now. So when we are calling it one more time, its value is now 1 based on this equation, plus another 1 that we are adding here. So the final value will be 2. So we expect that now when this function is called for the first time, it is going to print the xy value, new xy value to be equal to 1. And when we call it for the second time, it's going to call this function again and add another one value to the already existing value of the xy, which will be 2. So let me compile. Okay, great. So here we see that the initial counter is 0. Here we're printing the initial counter to be 0 because xy is a global variable and it is initially set to be 0. Then we are calling the function one time. We are calling the function. So we are adding one value to already existing value of xy, which is 0. So it will be 1. And we say counter after increment xy. So it will print 1. And then this block of code is executed and the program will go back here to execute the next line, which is increment counter for the second time. It comes back here. It is going to add another one value to the already existing value of xy, which is 1. So 1 plus 1 will be 2. So it is going to print 2. So this is how using global function will help us to access it through any function in the program. Thank you for watching, and don't forget to practice it by yourself. Hello everyone, and welcome back. In today's video, we are going to do another coding exercises with respect to the local and global variable in the function setting. So we would like to write a program that uses a local variable for us to store the values entered by the user. So the program should ask the user to input two numbers inside a function called add numbers. So far we know that we need to define a local variable. We need to have a function called add numbers, and that add numbers is going to read two input variables from the user, and then calculate the sum of the two variables, two numbers in the add number function and display the result. Ensure the variables used in add number function are not accessible outside the function. So this is exactly highlighting the definition of the local variable. So to do that, we have two functions, a main function, which is going to call our function here, our other function, and a void function that is called add number. So previously we learned how to ask a user to enter a number, how to store the number that is entered by the user, and how to do the mathematical operations. However, we are using a function to do that for us, to make the code cleaner. So here the int main function is very clean. We're just calling the function and nothing more. So these dirty parts are done before the main function. So now here we are applying the same concept that we learned before, like doing the mathematical operations and reading and storing the data from the user in a function. So using a local variables. So here, in order to do that, we have add number function, which is void. So it's not going to return any value, and there is no input for it because everything is going to be stored here. Instead, we could add some lines in the int main function and ask the user to give us the input value, like two numbers, and those two numbers could be input value for the add number function. For example, let me make it more clear. So we could have int a equals 10, int b equals 14, and then have a function like add numbers or whatever that was going to have a and b as the input variables. But here we are seeing error because this function is defined in a way that it has no argument as the input. Therefore, adding a and b here will cause some errors here for us. So that would have been another option to read and store the numbers in the int main function. But this could increase the complexity of coding in the input main function, in the int main function, and also make it a little bit, unclear. Instead of that, we are doing everything in add number. So here we are declaring two variables like x and y. And because they are defined in add numbers, they are inaccessible in any other function. So they are local variables. And we are asking the user enter the first number, we are storing it, then we are saying that, okay, enter the second number, and then we are storing it here. Then we are having another integer here that is called sum, and we are assigning the x plus y into that sum integer value, and then we are counting, we are printing the output saying that the sum of x and y is the sum here, which will be the value of the x and y. So let's see how it works first. So it says that enter the first number, I would say 10. Enter the second number, I would say 25. So it says that the sum of 10 and 25 is 35. So here it is asking the first number, storing it, second number, storing it, do the calculation and printing the output. However, in order to show that this was a local variable, if I uncomment this line saying that directly please print the x value for us, it says use of undeclared identifier. Why? Because x was already defined here as a local variable, and in this function it is not accessible. If we are talking about one x here, we need to define that x here, okay? And if this x is defined here and we are printing something here, like let me just put 50 here, and let's comment this part. So this printing syntax is going to print this x and not this x, okay? So because they are local. So this is how we need to as you see, when I commented this part, exactly the error came back because it says that use of the undeclared identifier. There is no x declared in the int main function. If we are meaning this x, it is not accessible from this main function because it is a local variable for the add number function. So we learned about how to do the mathematical operations, how to do our calculation using different functions to keep the int main function more clean, and we learned about the concept of local and global variable. Thank you for watching. Hello everyone, welcome back. Today we are going to talk about function declaration with default parameters or default values. So these functions in C++, we have a function with default value is a function where one or more of its parameters are given default values during the function declaration. This means if we call the function and do not provide the argument for those parameters, the default values are used. And if they are called and with argument, those arguments are going to overwrite the default values. So let's illustrate this with an example. Here we have the main function, here is another function. Here we have the greet, it's the name of the function and it's a void function. And previously we had like int x in the parentheses, so the argument of the function was like an integer, or input. Argument and input are the same, so I can use them interchangeably. So but here the argument of the function is a string which is called name here, okay? And the default value for this name is guest. So if we see this part like equals something in the parentheses in a function declaration, we realize that it's a function with default value. What does it mean? So first we go to the main function and we call the function. So when we are calling the function, you see here the argument is not given in this call. So when the argument is not given, this line, this part that is highlighted, would simply put the value guessed, would set the value guessed to the string name. So it would say, hello guest, welcome to the program. However, if we provide the argument and we call it here again, if we provide the argument, Alice would replace guest, and it would say, hello Alice, welcome to the program. Let's run the code once. Okay, great. So here we are seeing that the first time we are calling the function with no argument, and it is just simply saying, hello guest, welcome to the program. And the second time we are giving the argument to call the function, and it says, hello Alice, welcome to the program. So for the second time, Alice is replacing the word guest. So this function is very important to be used, because otherwise we had to write two functions. Now we are only using one function. So if we call it with no argument, it's going to put the default guest to name, and guest is going to be printed here. But if we are calling it with certain argument, it's going to replace guest with the called argument and then print the output. Thank you for watching. Hello everyone, welcome back. Now we are going to do one coding exercises with respect to the functions with default parameters or default values. So we would like to write a program with a function that calculates the total price after a discount. So the function should take the original price as a required parameter, and take the discount percentage as an optional parameter. So the default is 10%. So what I understand from this statement is that we need to write a function that calculates the discount. However, the discount amount by default is 10%, and there are some optional parameters that we can give, like 20, 30%, that they can calculate, the function can calculate it. So in this case, we need to have a function with a default value. Instead of having two functions, we can only write one function. So let's start from here. We start with the main function. So we print price after 10% of discount. Let's call the function calculate price. So let's go up in here to see the calculate price function. We see the name is calculate. The output is double, so it's going to return something, and it is indeed returning something. And in the parentheses, it is there are two arguments, there are two inputs. There are two arguments, one of which is price, the other one is discount. So both of them are double. However, price is a normal argument, but here the discount is a default parameter, because we are seeing that there is the equation sign here. So what it's going to do, here we are calling the function with the first argument only. So we are only sending the first argument, which is the price. We are saying that, okay, call the function for the price of 100. So 100 is set to the price here argument. Then we are going to declare a double that is called discounted price, and the discounted price equals price minus price times discount divided by 100. So it is going to give us the final price after the reduction of the discount. So it's a very straightforward formula. So what it's going to do is that, because we are calling the function only with the first argument, and since the second argument is a default parameter, so if we do not call the function with the second argument and only call it using the first argument, it's going to take 10% as the default value for the discount. So 10% is also assigned to this discount. And then the price minus, within parentheses, we have price times discount divided by 100. And the final price is stored in the discounted price, and we return the discounted price here, okay? And then we are saying that, again, see out price after 20% of discount. So let's call the same function, however, with two arguments in this time. So in this time, the price is still 100. However, because the second argument of the function is a default function, we are calling the function using two arguments, and the second argument is going to overwrite this default value of 10. So now that we are calling it with 120, it's going to replace 10 with 20. So let's run the code and see how it works, and then we are going to analyze the code once more. Okay. So here we are seeing that price after 10% discount will be $90. So if you do the math, you will realize that 10% of 100% would be $10, and the reduction would be $10, and the final price would be $90. However, in the second case, because we are calling the function with the second argument as well, this 20% is going to be set to the discount instead of 10. Now, discounted price equals 100 minus 100 times 20 divided by 100. And therefore, the output would be 80. So the overall lesson, the key lesson of this lecture was to be aware if you are working with a default function. For example, in this case, there are two arguments for this function. The first one is a normal argument, and the second one is the optional argument, a default argument, or let's say optional. So if we call the function, we must at least have one argument, because the first one is not optional. The first one is mandatory. So you cannot write something like this. So see out the price and then calculate price. So it returns error, you see, because the first argument is a must, because it's not an optional. How do we know that it's not optional? Because it does not have an equal sign. So at least if we are calling this function, we must have one argument, okay? So if we have one argument like this, let me just comment these two lines. If we are having one argument like this, it is going to put 50 as the price and 10 as the discount by default. So let's run. Okay, we see that the price is 45. Let me just print the C out so it goes to the next line. It would be nicer. So see. Okay. So here we see that the calculated price is 50. The calculated price is called by the number 50, and then 50 is for the price, and then the discount by default is 10. So the output would be 45. And if we call it with no argument, for sure there is an error. You see, it's not working because it says that this function has one must argument. So if you're calling this function, you must have at least one argument. If you want, you can have the second argument, but this is not mandatory. For in this case, I'm going to put 20. So 20 is going to be set to the discount instead of 10. Why? Because the second argument is an optional argument. How do I know that it's an optional argument? There is an equal sign here. So let's compile again. Okay, you see, with the 10%, we had the output of 45. Now with 20%, we have the output of 40. So this is an efficient way to write only one function instead of two. So by default, it's going to take the value 10, and we can change it to 5, to 2, to whatever that we want. For example, here now it's 5. And then if we are investigating one specific case, the optional argument can be changed as we are going to call it in the int main function. So please don't forget to practice these practices, these coding exercises. In the next lecture, I'm going to do further coding exercises regarding this function with default values. Hello everyone, welcome back. Today we are going to talk about call by value. So there are two ways to call a function. One of them is call by value and the other one is call by reference. In today's lecture, we're going to talk about call by value. Later on in this course, we're going also to talk about call by reference. So what is a call by value? So in a call by value, a copy of the actual parameter, the value passed to the function, is made and used inside the function. So any modification to the parameter inside the function do not affect the original value in the calling function. So when a function is called, the values of the arguments are copied into the function's parameter. So changes made to the parameter inside the function are local to the function and do not affect the original argument. And why is call by value is so important? Why is it so important? So the original values remain unchanged, which is useful when we don't want a function to modify our data. So basically, what it means is that when we are calling a function using a call by value method, if we are passing like two numbers to the function, these two numbers are copied here. There are certain tasks done here and the function result is obvious. Then whatever the modification inside this function is done is going to stay inside this function. So if num1 equals 10 and there are some modification here, still the num1 is going to stay equals to 10 in the main function. So whatever the modification is there. It's not going to affect the int main function. So here we are going to write a program where a function calculates the sum of two numbers. So the values passed to the function should not change in the main function. So when it says should not change in the main function, in the main program, we realize it's asking us to do a call by value. To do that, we have one main program here and one function here. So here in the main function, I am initializing two numbers like int num1 equals 10 and num2 equals 20. Then I call the function. When I call the function, I pass these two arguments, and these two arguments are integer and they're not optional variables because they are not having the equal sign like the default parameters, like the optional parameters. So when we are calling this function, we must have both arguments, and we must have these two arguments being passed to this function. And the name of the function and the function is a void type. So in the function, it's very straightforward. We're going to say int sum is initialized and then the value a plus b is set to sum. Here, we just mention whatever the integer we want to pass, but the name in the function is different. It's a and b. It could be anything. It's not important. So when num1 and num2 are passed here, num1 and num2 are going to replace int a and int b. Then it is going to do the addition, assign it to sum, and then see out the sum inside the function is, and print the value of sum. Then we are going to modify value a and b. So in this way, we are modifying the values passed to the function, but they are going to stay there locally. In these A equal to B and B equals to B does not affect num1 and num2 because it's a call by value. In order to make sure after this function is finished and the sum is printed here, and two modifications are done here, the sum is finished, then we go to the next line. So see out the value in the main function are still, we print num1 and we print num2 here and we return it. So let's run and see how it works. Okay, great. So we see that these two numbers are initialized and assigned values. Then we call the function, we go to the function, the addition is done, and the sum is printed. So it says the sum inside the function is 30. So the sum inside the function is 30. Here it means that 10 plus 20 is 30, so 30 is printed, and we are changing the value of A and B here. We are setting them to 0. However, when this function is finished, this line is finished, and then the program goes to this line. And when the program goes to this line, we will see that it says the value in the main are still 10 and 20. So these are the initial values set here. So these modifications are only for the local function and does not affect the main function. So this is the main purpose of calling by value. I would like to propose doing some exercises like this. So just solve and code this exercise yourself several times. In the next videos, we're going to solve some further exercises of call by value so we can see its importance. Hey everyone, welcome back. So we're going to do one coding exercises using call by value and show that using a call by value, when we call a function by value, it's not going to change the value of the original parameter, and it's going to change it only locally. So here we would like to write a program where a function attempts to swap two numbers using call by value. And we need to show the original values remained unchanged. So there are two things that we are going to learn. First, how to do the swap of two numbers using call by value, and also how to show that how to write these codes in the function and show that the original values remained unchanged. To do that, we have one main function and a swap function here. So we start from here. Every time you want to read your code, start from the main function, because whatever that is here is going to be executed. So here we are saying num1 equals 5, num2 equals 10. So we are initializing these two numbers, and we are saying that cout before function called num1 equals the value of num1 and num2 equals num2. So we expect that 5 and 10 is going to be printed here. Then we're calling the swap function and passing these two inputs or arguments. Then these two arguments are copied. Their original value is not going to go there. So a copy of them is going to go there because we are using a call by value. This is why the original number remains unchanged, in fact. So this function is called swap numbers. It's the name. There are two arguments. Both of them are integer, and the output, there is no output. It's a void function. To swap two numbers, one easy way and nice way is to define a new parameter. So here we are defining a new parameter. Just remember, like temp A and B. So we are firstly initializing a new parameter called temp, which is temporary. So we are putting a to temporary. So initially temp is empty, and the value of a is then set to temp. So the value of a is 5. So now temp equals 5. Then the value of b is assigned to a. So the value of b is 10, so it is assigned to a, so a is 10. And finally, the value of temp is assigned to b. So now temp is 5 and b will be 5. Okay, so one more time. So initially temp is empty. So the value of a is assigned to temp. So temp will be 5 because a is 5. Why a is 5? Because it's the first argument, and in the first argument we are passing num1 and num1 is 5. Okay, and num2 is 10. So the second argument is 10, therefore b is 10. So initially we are assigning a to temp, meaning that 5 equal, so temp equals 5. 5 is set to temp. Then we are putting whatever that is in b in a. So b is 10 and 10 is assigned to a. And in the last line, we are going to assign temp into b. So temp was 5 and 5 equals 10 then. 5 is assigned to b. Sorry. And then we are going to mention that inside the function, now a equals, we expect to have 10, a equals 10, and b equals, we are expecting to have it to be 5. So after doing all these modifications in this function, all of these are local. So we expect by swapping the values of the a and b, the values of num1 and num2 should not be affected because it's a call by value. So after this function is finished, then we are again here after function call, we are again printing num1 and num2 to make sure that everything is correct and these two remain unchanged. Let's run. Okay. So here, this line before function call, num1 equals 5, num2 equals 10. Okay. Then we are calling the function swap number. So here, as we went through the procedure twice, the procedure is done, so the numbers are swapped, and then we say, okay, inside the function, a is 10 and b is 5. Therefore, the numbers are swapped. Okay. However, when this function is finished and the code is here, and then it wants to execute this line, it says after function call num1, you see num1 remains 5, and num2 remains 10. So the swap procedure in the local function, locally in this function, did not impact the main function. So this is the main purpose of the call by value. Firstly, we learned how to swap two numbers. We need to there may be many ways to do it, but the easiest way is to define a new integer called here like temp, and then using that we can swap the numbers. And then we learned that even though we swap the numbers in the function, it's not going to impact the original value in the int main function because it was done here locally. However, if we were doing all of these tasks in the int main function, of course the swap would have worked and num1 in the end would have been 10 and num2 would have been 5. Thank you for watching. Hello everyone, welcome back. Today we're going to talk about call by references. So far we learned how to call a function by value, and we learned about the details. We did some coding exercises with respect to that. Today we're going to move on and focus on call by reference. So there are two main way to call a function. So the first one was call by value. Now we're going to focus on call by reference. So what a call by reference is. So in a call by reference, instead of passing a copy of the value, a function receives the reference or the memory address, let's say, of the variable. So this means that any changes made to the parameter inside the function directly affect the original value. Why? Because not receiving a copy of it, but its reference, which is the memory address. So it is going to directly manipulate and modify the original value. So when a function called, instead of creating a copy of the argument, the function works directly with the original value in call by reference. So let's learn it with an example. So here we're going to write a program that swaps two numbers using call by reference. So it wants us to define a function that swaps the value of two variables and call the function from the main function and show the values are swapped. Previously, we solved this program already with the call by value. There, only the numbers that were swapped in the function, they were locally changed, but in the main function, they didn't change. However, they are going to be changed here because we're calling them by reference. So basically, to do so, we know that we need to have two numbers and a function to do the swap for us. So here is our int main function, and here is another function that we have, the swap function. It's a void function, and the arguments of this function are two parameters. There are two arguments, let's say, and both of them are having integer data type. And so previously we were just writing down int a or int b. Now we are having this reference sign here, the and sign. So this and sign is for the call by reference. So this and sign means that go and check the address of where this argument is stored. Again, here this and sign means that go and check where the address of this b is and where it is stored. Let's dive in. So we initialize and declare two integers here, num1 and num2. The first one is 5 and the second one is 10. And we print the value of these two numbers, saying that before swapping, num1 equals 5 and num2 equals 10. Then we are going to call this swap numbers function, which is this one, and we are passing these two arguments, these two input values. So by passing these two arguments, the program, while being executed, will go and starts from here, which is the function, okay? So when it goes here, because the function is defined in a way to go and check the reference, it's going to check where the variable is initially and originally stored in the memory. Therefore, it is going to directly work with that. So this is why we call it call by reference, because it's going to check the reference and original place where the variable is storing. However, just note that when we are calling by reference, here nothing changes. It is exactly similar to the call by value. The change is only these two ands, okay? Then to do the swap, we define a new integer. We put the value of a into temp. So let me go through the analyzing of code like before. It would be easier for you to understand. So here we are having this, something like this. So temp is empty in the beginning. So the value of a is assigned to temp. So a is 5 because a is the first argument, and here the first argument is num1 and the num1 equals 5. So a is assigned to temp, so 5 is assigned to temp. Then b is assigned to a, so a equals 10. Why 10? Because b is the second argument, and here the second argument is num2, and num2 equals 10. So 10 is assigned to a, and finally temp is assigned to b. So temp was 5, and now 10 was assigned to b. So we did the swap using these three lines. Initially, a was 5, b was 10, but now after swapping, a is 10, b is 5. So done. We swapped the numbers. So when the function is finished here, this line of code is executed. So the program goes to this line where it is printing after swapping. So num1 equals, we print the value of num1 again, and we print the value of num2 again. So let's run and see how it works, and we're going to analyze the code once more. Okay, so here we see that the code is initializing these two variables, then it is printing before swapping num1 equals 5, num2 equals 10. So num1 equals 5, which is true, and num2 equals 10, which is again true because they were initialized just like 2 lines above. Then it is going to call this function. This function is going to swap these two values. However, because it's a call by reference using these two and signs, we know that if there is a change, it is going to impact these two numbers because it's a call by reference. So the swap procedure is done here. So this line is executed. Then the program is going to line 19. So, and it is printing after swapping num1 equals 10 and num2 equals 5. So we see that using call by reference, whatever we do, even locally in this function, since it's a call by reference, it's going to impact the original value of the numbers even in the int main function. So something to keep that in mind. So if I remove these two and, it will become like a call by value. So the the values are not going to change. So let's try them here. So you can see. Okay, as you see here, I removed the and sign here and the and sign here. So this is not a call by reference anymore. This is a call by value. So in this case, when a call by value is done, the program is executed like this. So it is printing 5 and 10 using this line, which is the original value. Then it is going to call this function. This function is doing the swap, and then when the function is finished, it is going to print again the values of num1 and num2. However, the values of num1 and num2 are exactly the same initial values because it's not a call by reference and it's a call by value. So in a call by value, we learned that we are not going to modify the original value but a copy of the value. So this is why we call it call by value. However, in a call by reference, we are giving the address where these two variables are stored. Therefore, the function is going to directly go there, find them, find the reference, and directly work with the original values. So I made it like to be call by reference again by adding these two ands. And we see here the first number is 5 and 10. It is printed. Then the function is called. And then when we are printing again the num1 and num2, the values have swapped. So this is important to know the differences between the call by value and call by reference, but because in different there are two different and separated things, and in programming, as per our need, we need to choose from either of them depending on what the goal of our program is. So keep that in mind, keep practicing, and try to play with call by reference and call by value by solving the exercises that I provided in different videos so you can master it. Thanks for watching. Hello everyone, welcome back. Today we are going to do another coding exercises using call by reference. So we would like to write a program where a function doubles the value of a number using call by reference. So we need to define a function. We are asked to define a function that modifies the value of the past variables. So call the function from the main function and show that the original variable is updated. So even if the program was not mentioning using call by reference, when they are saying that show that the original variable is updated, we need to get it, okay, it's talking about call by reference and not call by value. So in order to do that, we define a function that is going to modify the value of the past variable, and we need to write a function that doubles the value of a number. So here we have the main function, and here we have the function that does the work for us. So here it's a void function, and it is having only one argument, and it's an integer. And because it's a call by reference, we know that we need to put the and before the name of the integer. So the compiler would understand we're talking about call by reference. Okay, to do that, in the int main, we initialize the number to 15, then we print the value. We print the value, okay, we say before doubling number equals, and we print the value of it, which is expected to be 15 because we just initialize it. Then we are calling the double value function using one argument, and the argument is this number 15. And just note that in call by reference and in call by value, there is no difference for calling the function in this part. The only difference is this and added to the argument in the function declaration. Then this function gets the number address, so it is going to directly work with the original value and not a copy of it like call by value. And here it says, okay, whatever n is, make it multiplied by 2 and store it in n. So this way, the multiplied of the number is stored in n, and the function is done. So when the function is done, the program is going to execute the next line, and we are saying after doubling number equals, we expect to see 30. So let's check. Okay, great. So here it is 15. It's going to print 15, and it's going to do the doubling using this double value, and it is simply just performing this equation times 2. So whatever the number is past this n is here times 2, and then put it to the value of n. So modify it, update it. So if it's 15, it's going to be 15 times 2. If it's 10, 10 times 2, whatever the n is, that is passed here using the number that is initialized here. So it is going to be multiplied by 2. If I put 10 here instead of 15 and then pass the number, it is going to be 10 times 2. So then when it's done, it is going now to print the after doubling. So the value is updated because it's a call by reference. And if I want to make it like a call by value, I simply remove this and sign, I save, and I compile again. Okay, you see? So here, when it's a call by value, now it's not a call by reference anymore, it's a call by value. And you see that whatever modification in this function was, it doesn't matter. And the before and the after, like before doubling and after doubling, the value of the number remains the same. Why? It's a call by value now. It does not have the and sign. So it is going to work with a copy of the original number. When we put the sign, it is going to work with the original number directly, and it's going to update the original number and modifies it. So keep that in mind. It's very straightforward, but we need to do the practice to master it. Hello everyone, welcome back. Let's do another coding exercise using call by reference. So we would like to write a program where a function updates two numbers by reference. Add 10 to the first number, multiply the second number by 2, and then call the function and show both numbers are updated. When it says both numbers are updated, we know that we need to use call by reference, even if it was not being mentioned here. Okay, to do that, we have one int function and one function that does the work for us. The update value function, so update value is the name of the function. It's a void function. It is having two arguments. The first one is integer. The second one is also integer. The first one is x. The second one is named y. Because it's a call by reference, we have this and sign before the name of our integers. So we initialize two numbers, 20 and 15. They mentioned that add 10 to the first one and multiply the second one by 2. We say okay. So let's first print the numbers before doing any modification. So before doing any modification, we say before update num1 equals, we print number num1 like here, and we show this message, and then we print num2, which is 15. So we expect to see 20 and 15 by executing this line of the code. Then we are calling by reference this function. So here the first argument is x and the second argument is y. So the first argument and the second argument. And for the first one, we need to add it by 10. For the second one, we need to multiply it by 2. So x, we are adding whatever the value of x is, we are adding 10 values to it using plus equal. And then whatever the value of y is, we are multiplying it by 2 by star equal. We know from before, instead of writing, for example, instead of writing x equals x plus 10, we can write x plus equal 10. Okay, and we also know for efficiency, instead of writing y equals y star 2, we can simply say y star equal to. They does the same job, they do the same job, however it's more concise, so we are using this way. So it is simply just adding 10 values to whatever the value of x is, and it is multiplying y by 2, whatever the value of y is. So this function is very simple and it's done. When the execution of this line, this function is finished, it is going to next line where we are printing after update num1 equals, and then we are printing num1, and then we are printing num2. Here we are expecting to see different numbers. So the first number was 20. We added 10 values to it. So here we are expecting to see 30 now. And the initial num2 was 15, and we multiplied this by 2, and we are expecting to see 30 here. Let's compile. Okay, great. So we are seeing what we want to see. So 20 and 15 is passed to this function. Before passing, it says num1 equals 20, just like here, num2 equals 15, just like here. Then this function is called, we're going to this function. This function is adding 10 to the first num, so num1, instead of 20, it is now 30, which is shown here. And then the second argument, num2, which is y here, so it is multiplied by 2, and it is now 30. And this is what we wanted to do, and it did the job. So call by reference, modifying the original value. So please start doing the coding of these exercises that I do, and make errors, because when you make errors, you're going to learn from those errors and see how the syntaxes are working all together. It is very important to do that. Thank you for watching. Hello everyone, and welcome back. Today we are going to do one coding exercises using template functions. So we would like to write a program that swaps two values, the first value and two value of a function. So whatever we pass as an argument to a function, we would like this function to swap their place. So when we are, for example, passing two values like x and y, we would like to see in the output y and x. Okay, we would like to swap their values. To do that, we have a function, and it happens to be a template function, because we discussed that instead of having multiple functions doing the same thing for different outputs, like for integer, float, etc., we can have one unique function that does everything, and it has to be a type of template. So to do that, we know that we need to include this header. So the function that does the swap is the swap value. It's a void function. It's not returning anything. And as an argument, as the argument, it is taking two arguments. So their type is t. So it's a t. And then here we will see that it has the a and b argument. And they are called by reference because we have the and sign behind the name of the arguments. So when we have the and sign there, it means that it's a call by reference. And just please note that it's a void function and not a t function. So if it was supposed to have some output, we could write t here. Okay, so if it was going to return something in the end, so it could be t, so the output would be like t, a template, so the compiler would decide about that. However, we don't have any output. You see, we don't have any return. We are just doing some tasks here, and we are doing it by call by reference because we would like to actually modify the original values. Okay, let's try and see how this function works with different arguments. Initially, we define two integers. They are named x and y. Their values are 10 and 20. Then we have two float. Their names are p and q. One of them is 1.5 and the other one is 2.5. And lastly, we have two strings, str1 and str2. One of them is hello and the other one is word. So we would like to use these set of arguments to call this function to swap their values. So when we are going to call this function, in the end, the value of x should be equal to 20 and the value of y should be equal to 10. The same here and the same here. Let's see. So we are first printing before swapping x equals, so it will be 10 because we haven't done anything, and y equals, it will be 20 because we haven't done anything yet. Okay, then we are calling the swap function with our x and y. So with x and y, we are calling by reference the function. Why the reference? Because we see that we have the and sign, and when we are calling by reference using the and sign, it means that we are going to modify the original value. So the x and y will be modified here in the int main function. And we know how to swap the values. We define a new data type. The data type is template here because one time it's going to take int, one time it's going to be float, one time it's going to be a string. So it can be t. So therefore the compiler will decide what to choose as the type of this data. So we declare and initialize t. So whatever that is in a, we put it in t, in temp. Then whatever that is in b, we put it in a, and whatever that is in temp, we put it in b. This way we're going to swap the values. Then when this function has finished, so here we called the function with x and y. So we did the swap and this function is finished. So the program is going to execute this line. It is saying that after swapping x equals and y equals. So we expect that now that we are printing after swapping line, x will equal 20 and y will equal 10. The same here. So here we are saying that before swapping p equals, it's 1.5 and e equals 2.5. Then again, we are calling the function with these two arguments, p and q. Then it is going to treat the arguments the same as before. It's a call by reference still, so because we didn't change anything. And now t will be float. Previously it was integer, but now that we have the float arguments, it's going to be float. Then it is going to do the swapping, and after swapping we are printing the value of p and q. So p should be 2.5 in the end because it is changed, and q should be 1.5. Finally, we are printing before swapping the value of str1 and str2, which will be hello and word here. Then we call the function one more time with these two arguments that are strings, so it's going to be there, and then the t value will be chosen by the t data type will be chosen by the compiler, but in this case it's going to choose string because we have two string arguments. So it is going to swap their values, and after swapping, str1 should be equal to word and str2 should be equal to hello. Let's compile and see. Okay, great. So here we see, let's start from here. Okay, so we see before swapping x equals 10, y equals 20, exactly like this. Then after swapping x equals 20, y equals 10. So there are two lessons here. First, call by reference, it's going to modify the original value in not even if it's in another function. Second, we use the template data type. So the function, the compiler decided about the data type of the arguments and of the temp. And in our case, it was integer, so it's integer. Then we are having here, okay, before it's p equals 1.5 and q equals 2.5. This is exactly the same, so the assigned numbers unprinted. Then we call the swap value function. It does the swapping, and then we see that the value of p is 2.5 and q is 1.5. So it is changed. And finally, let me just get it above here so it would be also easy. Oops, sorry. So to also trace the program from here. Okay, so here we are printing the str1 and str2. So str1 is hello, str2 is word. So it is before swapping, it says str1 is hello and str2 is word. Then we call the function, we do the swapping here, and then after swapping, when we print str1 equals word and str2 equals hello. We see that using template function, we can do the swapping tasks. Not important, and it's not important the data type of the arguments. So whatever that is here, it is going to be adapted to that. So that's very nice. And then because we use the call by reference using this and these two and signs, it's going to modify the original value. Thank you very much for watching, and please do the exercises yourself, try them to see where you make mistakes. Those are the places you can learn from and improve your coding from there. Thank you very much for watching. If you haven't had the chance to rate this course, we would very much appreciate it to go and rate it. And also, please provide us with your constructive comments. It would help us to improve our teaching and our methods and our courses for future students. Thank you very much. Hello everyone, welcome back. So far we learned about call by value and call by reference. To make a summary, a call by value copy is a copy of the value, so it's not going to modify the original data and does not impact the original data. So when we don't want to modify the original data, we are going to use call by value. And when we would like to modify the original data, we are going to use call by reference. So a reference to the actual variable is used, therefore the original value is changed. However, today we're going to talk about template function. So a template function in C++ is a way to write a single function that works with different data types without rewriting the same function for each type. So instead of specifying the data type like int, float, or string, we can use a placeholder that the compiler replaces with the actual type during the compilation. So just write one function that works for multiple data types instead of creating separate functions for int, float, and other types. Let me explain it using an example. So previously, when we were talking about a function, we had the name of the function, we had the type of the output here, like if it was void, there was no output, otherwise int, a float, double, etc. So from this data type before the name of the function, we could understand the output of the function, the data type of the output of the function. And also in the parentheses, when we were having the arguments, we were having like int a, int b. So we were knowing that the input must be integer and not a double. So when we were talking about having int a, we knew that when we are going to call this function, we must pass the argument that is integer. And if it was defined to be an integer and we were passing like a double number, it was returning error. So in order to avoid writing different functions that works and do the same for us, do the same thing for us, but having different input and output, like we could write one function for the float, another function for double, another function for integers, another function for a string, etc. Instead of doing that, we can write a more generalized function and let the compiler decide about the type of the input and the output. To do that, we need to include this in the top on the top of our code, like template. Within the angle bracket, we have the type name t. So this is something that we need to include, like using namespace, std, etc. After including this, we can simply define the output of the function to be t and the input of and the types of the arguments or inputs to be also t, like here. Okay, when we did that, we can easily just use this function for integers, for doubles, for whatever we want. So let's see what we would like to write. We would like to write a template function that takes two inputs and returns the larger of the two. So the function should work for any data type, int, float, double, etc. So even if it was not directly mentioning to write a template function, by saying that the function should work for any data type, we could guess that it is asking for a template function because only a template function can do that for us. So let's dive into the code. So int main is having 3 lines only. So the first line says that max of 3 and 7, and then call the find max function with two numbers 3 and 7. Okay, when it is calling the function, it is going to start running the function. So using ternary operator, there is a condition here saying that in the condition, if you remember the ternary conditions, ternary operators, we were having like the first and the second. It is saying that A is greater than B. Okay, so this is the condition. The condition is separated from the possible outcome with a question mark. So these are two possible outcomes, and two possible outcomes are being separated with a colon. Okay, so it is saying if A is greater than B, return A. Okay, but if this condition is true, just return the first number, just return the first possible output. However, if this condition is not true, just return the second defined number. Okay, second defined uh, integer or variable here, second defined possible outcome here. Okay, so we are passing 3 and 7, and so 3 and 7 is here. So because 3 and 7 are integer, the compiler will realize that the arguments are integers. It is done automatically by the compiler. So it says 3, is it larger than 7? No, therefore, because it is not passing this condition, so it is not going to return A, but it is going to return B. So B is returned. Okay. Then uh, it goes to the next line, says that max of 4.5 and 2.3, and then calling the function, putting 4.5 and 2.3. So instead of uh, you know just defining another function, we can simply just use double or float number here, as you can see. So it is calling the function again. So the function automatically realized that, okay, we're talking about float numbers. So the arguments are floats, so the output should be float. And it is saying that, okay, it is checking the condition A and B. So A would be the first argument because it is A, and the second argument would be b, which is 2.3. It is mentioning, it is checking the condition that if 4.5 is bigger than 2.3, if this condition is true, which is true, the first condition, the first possible outcome, which is a, is returned. Okay, so 4.5 is returned. Then the program is executed and it goes to the last line. It is saying max of a and z. So basically, we can compare characters. Each of these characters are having an associate number. So it is going to say that, okay, find max with A and Z. It works for characters, okay? So we don't need to define a separate function. So the compiler will automatically realize, okay, we're comparing characters. It is going to check if A is greater than B. If this is true, A is going to be returned. If this condition is not true, B is going to be returned. So after analyzing the code, let's compile and see the results, and then we are going to do the checking one more time. Okay, so it is starting from here. It is saying that max of 3 and 7 is 7. It is integer value, both of them are integers. Integers are passed as arguments, and it is found that 7 is bigger, which is true. Then two float numbers are passed, like 4.5 and 2.3, and it is okay again because it's a t template function and we're putting t here. So the compiler automatically realizes that we are talking about float. And then it is finding the maximum between A and Z. And then it is comparing, and Z has the larger, let's say, behind the scene value, because each of the characters are associated with a number. So it starts with A, and as we move forward to B, C, etc., their associated value is going to increase. Therefore, Z having that, it is comparing those numbers with each other. So therefore Z is larger, and it is going to show Z in the output. So this is template function. It's very easy and it works very well when we don't know which data type that we are going to work with when we're calling this function. Therefore, the function will choose automatically the data type for us itself.